I would like to say first, welcome everybody to the conference on energy and sustainable built environment. We are organizing it third time this year online. I hope it will be useful and beneficial for everybody, and it will give all of us new insights on the progress on the different technologies in the field of building energy systems. We have very valuable presenters today from different parts of the world, and they will be talking on the different technologies, strategies, materials, those implemented in buildings for enhancing the sustainability. So, as we all are aware about the importance of the energy usage, efficient energy usage, there are novel ideas and novel systems, and it's always important and good to keep in track and follow these technologies. And this kind of organizations always helping us. I'm sure there are some undergraduate student friends, some researchers, some PhD level researchers, and there is something that we can all benefit from these presentations. I hope it would be useful for everybody. So just to summarize the plan, we have 4 different presentations in the first session. Then there will be a break around 40 minutes. And then we will have 6 more presentations in the afternoon session. And we will complete the conference. So firstly, we will start with Professor Olympia. Then we will continue with Dr. Hassela. After that, Dr. Francesco will be with us. He is also expert in European projects, etc. So this could be also useful for understanding the approach of European Union and their expectation in research projects. After that, Dr. Murat from Eastern Mediterranean will be with us, and he will be discussing mainly on building energy simulations. And in the afternoon session, we have Dr. Mahmoud Sami from Turkey, Necmettin Erbakan University. Then Dr. Melik, Dr. Meltem, Dr. Miguel, Dr. Muhittin, Dr. Pervin will be with us, and they will be also discussing on different approaches, active systems and passive systems, passive approaches in buildings for reduction of electricity usage, heating, cooling usage, or architectural aesthetics. So the main concern of us will be improving the building's performance from different aspects. So I want to give the word firstly to Professor Olympia. She is a professor in comparative history of architecture at Hosei University, Tokyo in Japan. And she has been research fellow at Kyoto University, Graduate School of Human and Environmental Studies, and vice president of ICOMOS Prerico and Asian Cultural Landscape Association. So please, Professor Olympia, I would like to give the word to you. You could share your screen and start your presentation, please. Thank you.
Thank you very much. It is a pleasure to today to be with you. And now I share my presentation. One moment, please. Do you see my presentation?
Yes, Professor.
Okay, thank you very much. It is a pleasure to join you, and I thank very much all colleagues Eastern Mediterranean University to invite me to this interesting conference and to share fundamental topics for the future of our common house. The main of this international conference allows us to open important reflection on our future and now to understand altogether that what the best way is to approach these issues and to resolve them. My presentation aims to introduce some issues and examples, but I am sure that the authoritative speakers who will follow me will analyze it in detail many interesting examples and aspects. In these last few years, many international congresses, conferences, and seminars have analyzed topics like poverty, sustainability, education, development of the local communities, social equities, and the United Nations 2030 agenda from 2015 defines important support for all institutions, governments, and international organizations that work to resolve these issues. These few weeks, we are assisted and we continue to participate in important meetings where political leaders, scientists, academic community, and the civil society are dialoguing to approach the crisis of our global system. Sorry, among the main topics, there is climate change and COP26, the World Leader Summit started in Rome and with its location in Glasgow, is allowing us to listen and know important suggestions and proposals for improving this sad situation of our sick world. The last few days, Mr. Obama, former president of USA, received ovation in this conference in Glasgow, introducing an important concept. This concept is adaptation. All society in the world have built on their development in relationship with the local specific need, and it is absolutely correct. But in many cases, these needs don't have respected the human right, the dignity of people, the environment, the law of nature, and above all, these specific needs have forgotten the main law of the organized or our life in the world. In general, the community have forgotten this this significance of the adaptation. This is the ability to know and to listen, observe, learn, and above all, building good solution for all. For this reason, I consider very important this word and the significance of this word adaptation. And I consider this word we need now to reflect about this concept. Now I consider this word very important because on this concept, only by respecting, knowing, and listening nature of law, we can find a correct way for the future. This law is a correct dialogue between people and environment. In general, above all, from last century, all communities in the world have never more looked for this dialogue because they took to be beyond nature. Today, the poverty, the severely inequality, the extermination, many animals, destruction, and the environment for specific and sectorial interests continues. But this poverty, this slavery, this extermination had beyond in another expression, in another form. For example, the totality addiction of the technology with the consequent social isolation, the not attention of the social problem realized from the technologies. But if the technologies replace people, now we must think about new activities and apply new vision for our future, because this is an important topic of no sustainability. Today, in the next few years, the international community will be called to approach and resolve very fast these issues that are the origin of the diet of the city. But what is a city? City represents an organized civic system where the citizens live and work, but when this system forgets the community, that is the origin of the city's concept. In these cases, we assist of the death of this civic organization. Rosario Assunto, an Italian philosopher, talked about the distinction between the city of Amfione and the city of Prometeo. The city of Amfione is the city that follows nature law, in contrast with the city of Prometeo, that this city destroyed this dialogue and promoted a supremacy of the man over nature. Also, Professor Salvatore Settis, Italian historian art and former director of School Normale Superiore in Pisa, in these last few years analyzed the many important books and scientific articles, these issues, and is affirmed the importance of the centrality of the community and the role of the cultural policies to understand the good practice of human sustainability. This semester, with my students in Tokyo, we are analyzing in detail the United Nations 2030 Agenda. Thanks to an important program that these last few years, the Japanese government has implemented in dialogue also with other important projects denominated Society 5.0. In detail, during this pandemic period, we are analyzing the death of the city and above all, the incorrect urban system generated in these last few years. And as this incorrect system was the origin of the city's death. Thanks to many observations that we have listened and dialoguing with the local community, we are studying the importance to plan in a different way the future cities. And now also we are understanding the best solution to regenerate the use of the metropolitan areas in dialogue with the new needs and the sustainability of the world. Tokyo, together with Mexico City, Istanbul in Turkey, Lagos in Nigeria, Delhi in India, Shanghai in China, are the biggest metropolitan area of the world where the community has suffered most from the pandemic. This said utile experience now allows us to start a new path where the new vision must improve the situation for regenerating main abandoned sites. In Japan, for example, the program Societies 5.0 is allowing to introduce new perspective to enhance above all the rural areas that many people are abandoned for living in the big city, but with a sad consequence. In many cases, these people have lived good a sustainability village for living in a sad condition in the metropolitan areas. The project Society 5.0 valorizes again the centrality of the people. And now, thanks to the technology, these programs intend to regenerate the rural area with specific support that in this next few years we allow us revitalize the many abandoned area with the new local economy and new local opportunity. Why? Because the community is our heritage. The community is the first heritage where the new we need to preserve. Here some photo of this area, this abandoned area that now we need to be regenerated in relationship also with the needs of the community. Also, the last trip with the students that we have realized in the first week of November in Kyushu, in the south of Japan, we have an important opportunity to visit Kumamoto Prefecture and above all this rural area. And in this rural area, we have understand the needs of the community and above all the needs of the new generation. Many people have abandoned the village to live in the city, but during the pandemic situation, many people are back again in this rural area to revitalize the local economy. All over the world, many people missed, for example, the job. And this event has been very important to understand the inheritance that they left in the past, and that now it is important regenerating and developing. For example, this is an interesting experience here in Japan. Different metropolitan area like Osaka and Tokyo, thanks to the local government institutions, are activated important projects to introduce again the valorization of many important territory for specific use as urban agriculture. On this path, also the school and academic institutions are working to approach the new generation to essential values of life. Also the program, and this is another image here in Tokyo, all in this area photo, I took this photo in Tokyo. But also an important opportunity is also an important program reconnecting with your culture in according with the point 4 of United Nations 2030 agenda, specifically dedicated to the point 4 quality education that we designed the last year and now activated in many countries in the world. This program aims the finality of to collaborate to realize these important goals, to approach the new generation of the local culture and above all to approach this new generation to the local values of their territory. this is the actual organization of this program in the world. When the city does, this is an important occasion, for example, also in Tokyo, for reading again the past and our heritage. And thanks to this experience altogether, we must work to beat a bitter world. Now, only together we can realize a good future. And I consider very important, for example, the experience of the COP26. And I suggest to you to read information about these events because it is very important, the result of this meeting, this international meeting. In conclusion, I want to share with you an important thing from an Indian writer, Susanna Roy. Susanna Roy invites us to imagine it, the world, our common house, in a different way. Invite us to last, to miss, to live our avarice, our ideas. And Susanna Roy invites us to open a new door, and thanks to this new door to imagine it another and a good world. I hope this path, this journey, it is possible, and I hope this journey is possible all together. Thank you very much for your kind attention.
Thank you, Professor. Thank you for your nice presentation. Actually, when I was listening, it came to my mind as engineers, I'm mechanical engineer. As we are engineers, we just think about some fundamental technologies, some specific technologies, and just try to develop these. However, understanding people, understanding their past, their culture, and developing strategies based on the needs of specific places is actually the key, because anything that we develop, investigate is maybe just suitable for a certain place, certain culture, or certain application. This is actually indicating that different researchers should work jointly, because first we should define what is the need in any specific place. Then maybe we should think about what we can do about this place. I think when we do multidisciplinary research, it could be much more beneficial, especially from now on in this new era after the pandemic. Hope collaborative research will be more popular. In some parts of the world it's popular, however still many parts, in many countries, researchers are doing individual research, which doesn't lead us to any point actually. So thank you very much for your presentation. It really gave me very good insights. Like I was just thinking about, we are in Cyprus, relatively less developed area. People are, there is a transition from towns to cities, people trying to adapt themselves to city life, struggling. They have roots in towns, and they have difficulty to live in city, and really some approaches to make the life sustainable needed. And it just gave me some insights. Maybe we should think something specific to areas, different areas. Thank you very much for the presentation. I would like to ask listeners if they have any question in their mind, anything to discuss with the professor, please feel free to ask your questions.
I consider very important the dialogue between different disciplines. For example, I teach in a faculty of engineering, and my students are engineers. And I consider it very, very important this cultural support in the project of engineering and also architecture. And in the future, the work, the interdisciplinary, the transcultural work, it is very important for the sustainability of the world.
Yes, Professor, definitely, especially engineering programs may be designed again because in the field of engineering, it's a bit lacking of social approach, social perspectives. We're purely thinking on maths and physics. However, in the current world, it's not sufficient. We should look at the broader picture. Just working on a specific technology is very important. However, thinking the whole is having greater importance.
Exactly. Yes. For this reason, it is important the transcultural and intercultural dialogue. Yeah,
definitely. Thank you again for your presentation.
It was a
pleasure for us. So I would like to invite the next speaker, Dr. Hassela Jarimi, from Solar Energy Research Institute from Malaysia, University of Kebangsan. So Dr. Hassela Jarimi is a research fellow at the Solar Energy Institute, and she obtained her BSc degree in physics from the University of Manchester in 2008, and later he completed his PhD in science. She specialized on solar energy technology. Before becoming a research fellow at the Solar Energy Research Institute in Malaysia, she was a research fellow in the UK at the University of Nottingham. And she has worked on several projects on smart glazing, PV glazing systems, also on thermal energy storage systems. And she is also one of the advisors of World Renewable Energy Network and member of World Society of Sustainable Energy Technologies. So I would like to give the word to Dr. Hassela Jarimi. She will be doing her presentation. Thank you.
Okay. Thank you, Deborah. And also thank you, Professor Olympia, for a very interesting talk just now. Can you see my full screen, Deborah?
Yes, Hassela, everything is fine.
All right, okay, thank you very much. Professor Olympia, actually I have some questions for you, but I will contact you after the conference to ask some questions. All right, thank you. Okay, hi, good morning and good afternoon for those who are coming from the same time zone as mine. I'm Hassela Jarimi, a research fellow at National University of Malaysia or University Kebangsan, Malaysia. First of all, I would like to thank Dr. Devram and Professor Utdu for inviting me to the conference today. So today I'm going to talk about a technology which is on building integrated photovoltaic thermal, specifically for facade application. Right. So basically my presentation today will cover the following topics, which are I'm going to talk very briefly on the fundamental of BIPV and BIPVT facade. And then I will share some of the different types of BIPVT facade and some of the technologies that have been recently researched on this topic. And finally, I'm going to discuss very briefly on the innovation in BIPVT facade which involves the research that I currently doing at Solar Energy Research Institute. So as an introduction, this is just briefly to introduce to everyone here. So basically for PV application for buildings, the PV or photovoltaic panel can be integrated or installed in 3 ways. The first one is the open rack mounted PV. So basically the PV system can be mounted on rooftops with a few inches gaps and parallel to the surface of the roof. And second type, we call it a building added or building applied PV, where it does not involve any integration into the building structure itself. So basically the PV panel is just placed on the surface of the building. But the third installation method is what we call as building integrated PV. In building integrated PV, so basically the PV panel is used to substitute or join into the building structure, such as a roof or other parts of the building, such as facades, windows, or balconies. So basically, in our in my discussion today, or in my presentation today, the focus of my presentation will be on the third type of the PV application in buildings, which is building integrated PV. So I think since like most of us here have experience with building structure, and I know that some of you here like even experts because you're architects and those who have involved in buildings. A building facade basically is a structure of a building that involves all the external faces of a building. So building facade is not an important element for the building because it is not only responsible as a primary barrier against any external weather elements, but at the same time, the building facade is also responsible for the aesthetic features of the building itself. In other words, building facade must be designed not only that it must be durable, but at the same time, we have to make sure that it contributes to low building energy consumption. And that's why architects, engineers, builders, they work hand in hand together to consider the implementation of the photovoltaic panel to replace the conventional building facade, so that what we will get is not only a building facade that can act as a barrier from the external weather element for the building, but also it can harness renewable energy for that building. So when we are speaking about the type of the PV panel that has been integrated for building integrated photovoltaic facade application, among the common types or the commercial types that are available are the opaque panel, the semi-transparent panel, and the semi-transparent panel, but with opaque PV panel, and semi-transparent panel that use thin film PV panel. So we know that with technology advancement, the efficiency of solar cell technology will increase, and the cost of the PV technology has basically shown a decreasing trend with the years. So as a result, we can see like growing numbers of successful projects around the world that demonstrates that conventional building cladding and roofing can effectively be replaced by active PV. However, we have to remember that only about 20% of this absorbed solar irradiance or radiation is converted into useful electricity, meaning that almost 80% of the absorbed solar radiation is wasted in the form of heat. So without heat removal, this will lead to the thermal stress to the PV structure, and at the same time, because of the PV performance is inversely proportional to its temperature, the increase in the PV temperature will definitely reduce the efficiency of the PV panel. So, like I mentioned just now, the system basically converts solar energy into electricity, but if we do not properly manage the thermal energy of the PV panel, so basically it will have a significant impact on the indoor environment as well. And as a result, it will increase the energy consumption by heating or cooling or ventilation systems in a building. I'm giving an example here. when I did a research at Nottingham University like 2 years ago on a project on thin film PV glazing, during winter time, we have observed like a temperature increase in the internal surface temperature of the PV, which is facing indoor, can reach up to 40 degrees Celsius, although the ambient temperature at that time was around 15 degrees Celsius. So from our simulation, we found out that if in the summer, this can be even worse. The temperature could reach up to 60 to 70 degrees Celsius. And we can imagine like the increase in the amount of the building cooling load if in the summer to overcome the increase in the heat gain due to the increase in the temperature of the PV panel. Now, so from here, what we can think about is, if only we can transform the heat into useful thermal energy, what we can get from the BIPV facade is a useful electricity and at the same time useful thermal energy from the same collector surface area. And this brings us to the definition of building integrated photovoltaic thermal facade, where the solar thermal collector and the PV collector is combined into one structure on the same collector surface area. So what we have is that if previously with BIPV, if we can only get electricity, this time what we will get is also a useful thermal energy, which we can also integrate with the existing hatchbacks or AHU system of the building. So a bit more on the energy analysis of the BIPVT facade. So this is an example of a simple energy balance equation of a BIPV facade. So if without the solar thermal component, what we will have is a situation where the absorbed solar radiation, which only about 10 to 20% produce electricity, and meanwhile, the rest will be wasted in the form of heat. But with the use of solar thermal component, which can be in the form of air or water as the working fluid, okay? Basically, the wasted heat can be extracted by the working fluid, okay? And then it will be transformed into useful thermal energy, which can later be supplied directly into the building, or it can also be stored in the thermal storage for the building application. Okay, here is an example of a BIPVT facade that uses air as the working fluid. It has double glass layer with air cavity between them. So for everyone's information, this space can be between like 20 centimeters to a few meters thick. And it will act as an insulation against extreme temperatures. But at the same time, the airflow will be flow in between these two glass layers and remove the unwanted heat from the PV panel or the PV glazing. And the second one, here is an example of a building integrated photovoltaic thermal facade, okay, which use water as the working fluid. So usually for this kind of design, the BIPVT facade is designed in such a way that the absorber is attached directly behind the surface of the PV panel. And usually the type of the PV panel that is being used is the opaque type. And some innovation in the BIPVT facade, there are also some researchers who have integrated BIPVT facade with pump. So basically in this design, what they have done is the evaporator part of the air source heat pump is linked to the heated air from the BIPVT. So as a result, the COP of the air source heat pump increasing, but at the same time, because the PV is being cooled by the working fluid, we will also see an increment in the PV performance of the BIPVT facade. All right, here is another innovation in BIPVT, which is done by a group of researchers in China, where they have integrated the use of BIPVT with phase change material. So basically, this is how it works. Like in the summer, the PCM, the phase change material, will store the heat from the PV panel and also the heat gain from the building. And this heat will later on be removed from the upper shield of the wall. Meanwhile, in the winter, the PCM will perform as a heat storage, which later on being supplied to the building. So during the day, the PCM will store the solar heat gain from the PV and the building, and during night time, it will supply the heat back into the room. Okay, now I will share some of the case studies on BIPVT facade. And actually, the research is quite interesting because the research has been conducted as early as in 2006. And this is an example of field testing that has been done in Lisbon, Portugal. So from their report in 2012, okay, they have found that the air working fluid, okay, which has been used to remove the heat from the BIPV facade, can actually reach temperature up to 30 degrees Celsius during winter. So as you can see here, the blue arrow here, okay, is showing the air inlet, and the red arrow here is showing the air outlet. So from this kind of arrangement, okay, they have found that the temperature that can be supplied into the building, okay, the air temperature that can be supplied back into the building for the space heating is as high as 30 degrees Celsius. If that was an example of BIPVT using air as a working fluid, this is an example of a case study that has been done by a group of researchers in Hong Kong, where they have implemented the use of circulated water, or they have used water to remove the unwanted heat from the PV, and then they store the water for later for domestic heating application for that building. And one of the things that has been pointed out by the researchers is that although this kind of technology is very appealing, but we have to remember that because of its vertical configuration, or because it is in facade configuration, the collector is basically not at its optimum condition because it is not being tilted at its optimum angle. Nevertheless, the researchers has found out that the maximum efficiency that they can get from the system was as high as 40% for the thermal part and as high as 10% for the PV part. And the next case study that I would like to share is a case study of a researcher who has done this field testing in Canada. This is an example. Okay, this is an example where the BIPVT has been installed or employed for a high-rise building, as you can see at the top building here. This is the BIPVT facade. But for this case, they have used an unglazed transpired solar collector to collect, to allow the flow of the cold air, and which later on the air was basically performed as a working fluid that removed the heat from the PV panel. And in this case, in this application, they basically have integrate the system with the existing air handling unit, or the hatchback system in that building. And it's quite interesting because of the installation of the PV panel, the installation of the BIPVT facade, which is like at a high-rise location, which is free from shadow and so on. So they basically have found that the annual electricity production that they managed to get from this installation is as high as 22 megawatt per year, and meanwhile the heat that they get is as high as 55 megawatt per hour, megawatt hour per year. Okay, next. So basically the 3 or 4 studies that I have shared just now was quite studies that have been done in the past 10 or 20 years. But for recent years, okay, this kind of research also has been gaining attention by researchers in Korea, for example. So this is an example of a field study that has been done in Korea for a building for educational research facility in Korea. So this is another example where they have employed air as a working fluid. So for this arrangement, it's quite interesting because they found that the outlet air temperature can reach up to 40 degrees Celsius when the inlet air temperature is around 20 degrees Celsius. So for this kind of design, during the time when they do not need the heated air for the space heating for the building, so basically they will exhaust the air to the ambient. Meanwhile, if the air is needed, it will be supplied directly to the building. And they also found that the temperature, the PV internal temperature could reach up to 47 degrees Celsius. And this is also another example, also done in Korea. From their research, they found that the Bipvd system in general can supply air temperature up to 32 degrees Celsius, which was 15 degrees higher than the outdoor air temperature. So meaning that although we know that air temperature although we know that air is a poor heat transfer, has poor heat transfer property due to low heat capacity, nevertheless, for a building application, for Bipvd application, because it involves a large surface area, we can see that the temperature can actually reach up to 32 degrees Celsius. And most importantly, the same technology will also produce high-grade energy in the form of electricity, of which as high as 30 watt electricity, in such a way that they found out that in comparison to the Bipv system, because the PV has now been cooled by the working fluid, it can now produce 30 watt more power than the conventional Bipv system. All right, so far I have talked about what is Bipv, what is Bipvd, some of the case studies. Okay, now I'm going to share the research or the study that we are conducting in National University of Malaysia in Solar Energy Research Institute. So far, what we have found is that most of the research or studies on Bipvd facade has been focusing on flat type. But flat type, like I mentioned earlier, is not very efficient because it is not tilted in its optimum configuration. So in our institute, we have proposed an idea to maximize the energy production from the solar collector, of which we are proposing the use of asymmetric compound parabolic concentrator together with double pass solar air collector. And we have specifically designed the CPC to be in a symmetrical shape, right? Because the conventional CPC is symmetrical, but for our design, we have specifically designed it to be asymmetrical, meaning that the acceptance angle are not the same. So the idea is that with the asymmetric CPC configuration, we will be able to increase its acceptance angle, and therefore in our research, because we take into consideration the change in the incidence angle that varies significantly throughout the year, depending on time and location of the year, we believe that with asymmetric, it's not that we believe, okay, we've done research, okay, with asymmetric CPC, basically we can maximize the amount of the energy yield from the Bipvd facade. So in our research, I would like to share some of the preliminary results. Okay, it's very interesting because from our simulation and from our analysis using validated equations, we found out that it is very obvious that with asymmetric CPC configuration, we can find a point where the solar irradiation absorbed, the yearly absorbed solar irradiation is actually the highest or the maximum with SCPC configuration, depending on the location. This is also some of the results that we have found. So basically from our numerical modeling, we found that the maximum energy yield can be as high as 50% for high latitude countries. Meanwhile, for mid and low latitude countries, we have found that the increase in the yearly absorbed solar radiation the yearly energy produced can be as high as 14% in comparison to CPC with flat plate solar collector. And last but not least, using the validated mathematical model, we have used Transist and MATLAB to analyze the building heating load demand analysis, and we found that with solar fraction of as high as 60%, we managed to get an acceptable range of output temperature from the solar facade, and we found that it is suitable for space heating application at certain month of the year for high latitude country. Okay, I think that's all for today. I'm sorry, because I've exceeded 1 minute on the presentation. Thank you. Okay. Right.
Thank you, Hassela.
Thank you,
Very nice presentation and just on time. Actually, I was getting ready to warn you, but you just finished on time. Thank you. Thank you for this. I just have one question in my mind. So you are expert in this field. So if we just think about the photovoltaic efficiency, did you do any analysis before, like in terms of the PV efficiency in flat plate applications? Like what could be the improvement in efficiency of the photovoltaics? Can we obtain a few % increase? Did you get any?
Yes, in general, like the graph that I showed just now shows you like the total yield. The total yield basically is the combination of the solar thermal and electrical. But if I didn't show you the graph where I individually analyze the energy in terms of electrical and thermal, but if we look closely, there's definitely an increase in the electrical efficiency of the PV panel.
Okay, thank you very much, Hassela. I just want to ask to the listeners if they have any question about this novel technology. Please feel free to ask your questions. Any question?
Hello.
Hello.
Yes.
Could you hear me? My name is Murat, and I am one of the students at Eastern Mediterranean University. So your presentation was perfect. Thank you so much for that, first of all. And actually, I have two questions. So first of all, I would like to start with double glass wall. My question is that what should be the amount of space distance between the two glasses? Because I saw there are two glasses, and how does it affect on efficiency? Could you explain that for me?
The two glasses, okay. So I speaking about double glazing or the two glasses in BIPVT facade application?
The second one.
Oh, for BIPVT facade application. Okay, for that, to answer your questions, it has to be depending on the weather condition, and also so basically what you have to do is you have to do a simulation studies to check what is the optimum gap between the two glass layers, because the idea is like this. If you have too big of layers, okay, if the gap is too wide, okay, what you will experience is definitely a drop in the heat transfer by the air collector, because the heat transfer by convection will reduce when the gap of the air gap is increases. But at the same time, we also have, it depends, that's why I say depending on your location. It also depends on your location, because the gap also perform as the insulation layer for your building. So there must be a trade-off between the insulation for your building, okay, which is to reduce the heat gain or the heat loss of your building, but at the same time you have to make sure that the gap is just sufficient or optimum for the working flow of the air working fluid, right? So to answer your questions, I cannot say, oh yes, please use 15, please use 10 or centimeter, or please use 1 meter or 50 centimeter. It has to depend on the simulation studies, and it depends on the location of the building of the BIPVT facade installation. I hope I answered your question on that.
That's so sensible. Thank you so much. And my second question is about the PVT wall. So I saw at your presentation some PV panels which are connected on the wall, so they were assembled parallel to the wall. So will not the angle of the panels affect the situation here? Because it's parallel, so like sometimes may not benefit from sun rays.
Oh, yes, absolutely. That's why yes, absolutely. That's why I mentioned in my presentation just now, one of the limitation of the BIPVT facade is that the PV panel is installed in a vertical wall, in a vertical configuration. So from the perspective of the installation of the PV panel, so we also have to consider the effect of shadow and so on. But if you are talking about because it is not being installed in its optimum tilt angle configuration, definitely it will give an effect to the overall performance of the BIPVT. But you have to remember, the thing about BIPVT facade is that it covers a huge surface of the building structure. So this is, as a result, this will overcome the shortcomings of installation of the PV in a facade application. In the facade.
I would like to ask that question because, as you know, because of like parallel position, it will create a shade, and like just I assume how it will work. And like I would like to work in the future like about that topic, about that case. So thank you so much for your answering. I really like glad to meet with you and listen to you. Thank you so much.
Okay, thank you very much. All right, thank you.
Okay, before losing time, because we already exceed the time, I would like to give the word to Dr. Murat because time is running. So Dr. Murat, you could start now. Thank you. So I want to give a brief information about Dr. Murat as well. He gained his BSc in 2006 from Mechanical Engineering Department, Çukurova University in Turkey. Then he received his MSc in Mechanical Engineering Department in Eastern Mediterranean University. Then he got his PhD degree from the University of Manchester. And his main research interests are building heat transfer, building thermal performance simulation, phase change materials, energy auditing, and passive buildings. Thank you.
Dr. Devrim, thank you very much for giving this opportunity to me. And let me share my screen. Okay, I believe you do see my screen.
Yes, thank you.
Okay, thank you very much again. Sorry, maybe you are not recognizing my face because there are plenty of sunshine coming from my back. Sorry for that. And well, I will present the topic, Building Energy Performance Simulation, a practice for sustainable approach. My name is Murat Özdenefe. As Dr. Devrim introduced me, I'm a lecturer in Department of Mechanical Engineering at Eastern Mediterranean University. I'm also board member of the Energy Research Center in Eastern Mediterranean University. Well, I would like to start with the meaning of the sustainable development. Well, it is made up from two words, sustainable and development. Let's have a look. What do they mean? Sustainable means conserving an ecological balance by avoiding depletion of natural resources. And development means the process of growth or being developed, or the process in which someone or something grows or changes and becomes more advanced. Well, what about the meaning of the phrase sustainable development? Its definition is put by United Nations as the development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. This definition is done by the UN in the General Assembly in 1987. Well, Dr. Olympia mentioned the 2030 Agenda for Sustainable Development. The UN member states in 2015 adopted, agreed this agenda, and this agenda is a blueprint for peace and prosperity for people and our planet for now and in the future, and it involves 17 sustainable development goals. Well, these goals recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, boost the economic growth, all while tackling the climate change and working to preserve our oceans and forests. Okay, why this is not proceeding? Right. Well, these are the goals, their colleagues: no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy. This is the one which I will talk about a bit more today, since I'm working on the energy field, particularly energy performance simulation, energy efficiency, etc. Well, what is this goal? Sustainable Development Goal number 7. It is for ensuring access to affordable, reliable, sustainable and modern energy for all. And it involves some targets to be achieved by 2030. What are those targets? Universal access to affordable, reliable, and modern energy services, increase the share of the renewable energy in the energy mix, double the global rate of improvement in energy efficiency, and hence the cooperation to facilitate access to clean energy research and technology, and expand the infrastructure for supplying modern and sustainable energy services. Well, I'm going to focus on the efficiency, and particularly I will put emphasis on the buildings. The reason is that because the buildings' energy consumption is huge. Well, here you do see the energy consumption of the building sector in European Union, United States, and in the world. It is obvious that in the EU, they consume the maximum energy. In USA too, in the world, they are the second sector which consumes the most energy. Well, that is why we need to focus on buildings. They consume plenty. Better design of buildings therefore may yield up to 50% of reduction in their energy consumption, and smart retrofit strategies for the existing buildings can lead up to 30% in energy consumption reduction, and this obviously will reduce a country's energy demand, will contribute the climate change mitigation, and better designs, of course, will ease the effect of a stressful indoor environment imposed by poor designs. Well, here comes building energy performance simulation. Well, I should put this, the energy efficiency should be thought as an untapped clean energy resource of vast potential that could be only exploited by smart designs and retrofits. But there are barriers to get access to this clean energy resource. What are those barriers? Ineffective decision making and insufficient expertise. Well, here comes the building energy simulation. It emerges as a must for uprising various design or retrofit options for effective decision making in order to achieve and exploit this energy resource, which is energy efficiency, as well as to meet people's welfare in the indoor environment. Well, this practice, building energy simulation, enjoys rapid momentum of transfer into the practice because of the general acceptance of being the best practice. Well, it can be taught as the best practice because first, it addresses buildings' two main aspects, hard and soft. Well, hard aspects are the physics based on laws, and the soft aspects, which are the stochastic behaviors of the occupants. You are able to address those aspects with building energy performance simulation. Well, second reason is this, that it enables swift cost appraise and alternative design approaches. Well, I will go a bit deeper for the hard and soft aspects of the buildings and the appraisal of the design alternatives by using building energy simulation tools. Sorry, my slide is not moving. Okay, I have to press several times to my mouse. Let's have a look to the hard aspects first. These are the physics-based laws that relates the buildings with its environment. This environment could be outdoor environment and indoor environment. Of course, the buildings are not suspended in the void. They are in an environment, and there is internal environment which occupants are exposed. There are also different items in the buildings, and these are all interact with each other, and those interactions can be modeled by associated physical laws. The external environment is usually interaction with the external shell of the building. There is external convection with the outer surface of the building. There is external long wave radiation exchange. Solar radiation hits to the outer shell of the building, and if there is glazing, it propagates through the glazing and it reaches to the indoor environment. There is infiltration, exfiltration through the openings. Well, there are interactions in the indoor environment. The occupants and the other items are exchanging convective heat with the indoor air, long wave radiation with the surrounding surfaces, and there may be conduction as well. The other surfaces in the indoor environment also interacts with each other, and these are all can be addressed by building energy simulation. Well, the soft aspects, this is due to the stochastic occupant behavior. In a single building, you may have different occupants behaving differently. For instance, an occupant may turn on his stove, closing his curtain, enjoying his time, reading his newspaper. Another occupant may do a workout, therefore he's hot, he is turning his fan on or AC system on. Another occupant is on the other side of the building and enjoys sunshine, and maybe another occupant is trying to sleep. And this picture here shows the stochastic occupant behavior, and to an extent you are able to model this aspect of the buildings. Well, a second reason why the building energy performance simulation can be considered as the best practice, because it enables swift cost uprise and alternative design approaches. An example, you want to design a building, its west facade is full of glazing, window to wall ratio is about 40%, and you want to do a swift cost uprise if the window to wall ratio on the west facade is 0. What would be the price difference? You could do this swiftly, or you may want to investigate what would be the energy consumption of the building if you change its orientation. These are all straightforward with energy performance simulation. Well, I will go a brief history of the simulation. Previously, people were using static design methods to evaluate the energy consumption of the buildings, and those methods fall short to satisfy the hard and soft aspects of the buildings, and they're not enough for a rapid uprise of different design options.
Dr. Murat, if you can summarize in 10 minutes, it would be helpful because we already exceed the time.
Okay, Dr. Devrim, sorry, I will try my best. Let me increase my pace. Well, all design methods, they reduce the complexity, they neglect the system, some system items or time invariant system parameters, and they have done simplified assumptions. Therefore, they fall behind energy performance simulations. Here is a brief history of the old design tools. I will skip that, but let me put some emphasis on this. They were reducing the complexity of the buildings, and here is an example. Before, in order to evaluate the convection heat transfer from indoor surface to the indoor air, you could assume a constant convection heat transfer coefficient, and you may use it. However, that would not reflect the reality. Whereas in building energy performance simulation, you may follow a dynamic approach. You may use different convection coefficients for different surfaces, and these are all time dependent. The temperature of the surface and the indoor air is changing. Therefore, the H value will change at different time steps. Well, neglected system items, you are not able to model advanced materials such as phase change materials with old methods. However, this is possible with dynamic methods. And old methods are doing simplified assumptions, steady state or steady cyclic, but this is just intuitive and gives a straightforward approach. It does not reflect reality closely, whereas with building performance simulation, you may use different models such as finite difference approach for modeling the conduction through opaque materials of the buildings. Well, I want to show you some applications for building energy performance simulation. First one is an optimization study for a virtual building. It's an attempt to minimize the site energy consumption and discomfort hours for a generic office located in Cyprus. By how? By varying the window to wall ratio and the orientation. The tool that is used is Design Builder. It's a commercial software, and it is using Energy Plus as the simulation engine. These are some features of the location: heating design day temperature, cooling design day temperature, and below you do see the building. It is an office building. It is made up from several zones, and here you do see its features: gross area 900 meters square, occupied volume, window to wall ratio is 30%. This value will be changed in order to minimize the energy consumption and discomfort hours. This is the human activity and air conditioning availability schedule. It's an office building. It is occupied from 8 till 5. Material properties of the building are given here. Well, I assign a simple generic unitary air-to-air heat pump. COP values are given. Heating COP, these are seasonal COPs. 2 cooling system, seasonal COP 2.5. I think I use the default values. And this is the system topology. It is very simple, straightforward. And I did one simulation. And the site energy consumption, site electrical energy consumption is found to be 46 megawatt hour. This is annual energy consumption. Well, this is a single data point. And then I run an optimization study. Well, each point here represents a particular model, particular window to wall ratio, and a particular orientation. And this is after iteration 39, iteration 355, 1695, 2000, and after 4000 Pareto fronts start to appear. Well, what is Pareto front? It shows the optimal solutions. Well, 2 limiting cases here. One giving the minimum energy, the green one. The other one gives the minimum number of discomfort hours. So you, of course, better to pick something in between. Of course, this depends on your targets. Well, that is an optimization application. Here is another application. It is an attempt to test and validate a particular module, which is conduction finite difference module of Energy Plus for Trombe wall applications. First, what is Trombe wall? It's a passive heating system. It's a massive wall, usually placed on the southern facade of buildings. It collects solar energy during daytime, and it radiates this collected heat to the space for heating during winter. And there is a glazing in front of this wall in order to prevent thermal losses. Well, we do have a test room in our university, in our department. It is intended to be used for research, and its south facade does have a trauma wall. Its thickness is 16 centimeter. Its area is about 12 meters square. Material is reinforced concrete. What we have done here, we monitored the nodal temperatures, the temperatures in the wall. We monitored the solar radiation, and we did modeling with Energy Plus by using the conduction finite difference algorithm, and we compare the results in order to validate the model. We use K-type thermocouples, pyranometer for measuring the solar radiation, and we use data acquisition system for logging the data. And this is the schematics of our experimental setup. This is the modeled test room, and we use conduction finite difference algorithm approach in the model. We tested different space discretization constants, and we compared with the measured values. Here are some results. The top chart is the monitored values. The bottom one are the simulations, and here you do see the node temperatures comparisons for a day in February. The values are matching. There are some discrepancies, particularly for the central nodes, and but mostly the results are matching. You can see this clearly from the cumulative distribution of occurrence of the nodal temperatures for the measurement period. It was about 2 months in winter. Well, I'm almost done, Devrim Hoca, just 3-4 slides left. Another application, testing the PVs. Well, the frame on top of this building now involves PV panels. You don't see it here, but they are there now, and they will be movable. The capacity is 1.5 kilowatts. We have an inverter, and the PVs are generating electricity and it's giving the grid. We will test the increase in the energy production with the PV panel by changing its tilt angle. Also, it will help to prevent the solar radiation to fall on the tromba wall during summertime. We do not want solar radiation too much in the summer for heating, so we would use the PV panels to prevent solar radiation to fall on the tromba wall during summertime. And during summertime, the tilt angle will be low. We want a low tilt angle during summertime. The sun is high during the summer, so we will also increase the production, electricity production from the PVs. Right, some preliminary results for production from our PV panels. Right, that's it. Thank you very much for listening. I think I'm on time.
Yeah, thank you, Dr. Murat. Just on time. Thank you for the very comprehensive presentation, especially about the building energy simulation, which makes the life easier for evaluating any potential technology for the buildings. I believe for several researchers, it was a very beneficial source. Everybody can get something from this, and maybe the ones who are willing to study in this area or who are working already in this area, you would share your questions and ideas with Dr. Murat, and maybe it can lead you to a future collaboration as well. Without losing too much time, I would like to move to the next speaker, Dr. Francesco Mateoji. He will be the next speaker. He's an innovation manager with 20 years of experience spent as a researcher in material science as a corporate R&D manager within the field of technologies for renewable energy production and storage, and as an intermediary of knowledge trying to exploit the research results within the field of energy and environment. So Francesco Mateoji has wide range of experience in both research and managing entrepreneurship areas. I would like to give the word to him for his presentation. You can start, Dr. Francesco.
Good morning to everybody. Thank you to the organizers. I will try to move the attention from the pure research, where I will only dedicate a few seconds at the end of the presentation, showing some examples, to the concept of what might be needed to scale up, I mean, the deep tech innovation in the green field. So just to start, I think it's necessary to give a definition of what we consider in European Commission deep tech, and on the other side, what is also, you know, the issues when you have to scale up something. I made a mistake, so I come back to the presentation. Here we are. And then showing you some examples of deep tech projects for the built environment. So start deep tech, what is it? It does not exist a unanimous definition of deep tech. I like to take the definition from this source, that is a paper, a report paper written by Boston Consulting Group and Hello Tomorrow, where they shortly say that deep tech is something more than the science-based innovation, because it starts, as is written here in red, from problem-oriented. So we start from a problem. When I speak about deep tech-oriented, we want to solve it, but to solve it, you need the science. You don't need the single science, but you need the multidisciplinary science. And another characteristics is the fact that it's a high risk. So it's a high risk setting up the innovation. So high risk means that the impact can be good, can be high, but in the meantime, you need long-term and a lot of money. And in the end, when we speak about deep tech, normally software is not the focus. Software is the part of the hardware. So we're speaking about deep tech when we see hardware going on. So materials, technologies, something like devices. And in the end, the important is the approach. When we speak about deep tech, we consider the DBTL approach, that is design, build, test, and learn, where it means that in a multidisciplinary group, we try to design the things, we try to understand exactly where the things are moving, and once the things are moving and we design it, we test. We build the testing facility, but we test the device, the technology, the material for its final application in order to see if it is possible and feasible to solve the problem. But the most important part is the last L, the learn. It means, so we design, we build the facility to test it, we test it, but then we learn what is going on. And by the approach, we understand the results, and it is part of the iterative approach, typical of innovation, that, as we all know, it's not a linear process, but it's a complex process that requires iterative approaches. And so when we face this huge challenge of deep tech, we have to consider that it's necessary, as I said before, in the designing part, to organize the things. We have to find in an easy way the definition of manage can be seen as using the best way resources to get deliverables, to get results. But which kind of resources? When we speak about innovation, the main resources are people and money. So we need the right people, the right money, but we also need to manage them appropriately, to organize them, to really focus them, to increase their motivation. And so it's crucial, in my humble opinion, when we start the project and we really want to go through the details of the project, to plan all the actions. And that's the first thing. The second one is just the process. How can we see the process? We can see the process in this figure, like the play we were doing when we were kids, grouping the different things. But before grouping the different things, what we need is to find the right approach or the right process. We see here, we can go from top left to top right in one jump, but we can also go following the different steps. And to follow the different steps, it means we have to identify some patterns. And unfortunately, it's almost impossible in innovation to follow the short track of the red arrow. So it means that we have to follow the blue path to get to the final results. But the blue path requires a procedure, a certain organization, certain steps. And so the first step, as I said, is the organization of the resources. The second one is the capability, what is called in innovation management ambidexterity, the capability to look at the long term. So to look with the science eyes, but also to look contemporary at the short term at the business. We have to focus. As I said before, the DPTL approach requires certain testing, learning and repeating the things, but we do not need what is typical of scientists to make the best out of our research, of our knowledge. No, business teaches us that at a certain point we have to focus on an application to develop the right device or technologies that is needed by the market. And it is here that the group of people, multidisciplinary approach, not only in terms of disciplines like physics and chemistry, but also like science and business, have to speak the same language, to work together, to cooperate, to look at short and long term. And another important fact when we speak about short term is to know the market. We need, as I said before, mainly to focus on a customer, on the first customer, on the first application. Why do we want to focus it? Because we know it. We know which is the best application to first focus, because we have a strong know-how in terms of intelligence. We have a lot of data, so we have to look for reliable data. We have to look for useful data. We have to manage this data. We have to study and also to identify the added value of our, of our technology, the technology where we are working, to identify, so the added value compared to the other technologies. Why people should buy my technology? Why should I sell my technology to other partners? Why should I get the license agreement with a certain corporate if they want this? And to do this, for sure, it is necessary to put in place the right communication strategy, because if we are able to communicate to different communities, it means that we are able a lot to make the things work properly and to make the things and the people work in the right direction, different people. And for sure, when we look at the exploitation, we have to put in place the right business model. And as I said before at the beginning, we need the right team to make it work. And so we have to work a lot to find the right people, motivated people, to define very well which are the job description, to understand that not always the scientist will be the right person to bring his technology to the market. Normally, it is said in US that to put in place a company, you need three main minds, in particular when we're speaking about, companies knowledge-driven. You need a CEO, that is the person managing everything, knowing, but not so much loving the technology, but loving make money out of its team know-how. This is the CEO. Then you have got the CTO, the Chief Technical Officer, or the CSO, the Chief Scientific Officer. That should be the researcher, the scientist behind, because he will look, as I was saying before, at the long term. It's the CEO looking at the short term. And combining the short and the long term, it's an issue of the CEO. The CTO have to develop the technology at the relevant level, quality requested by the market. And he has to be given this focus. And the third person is the CFO, the Chief Financial Officer, the person that is able to get the right money at the right moment and to use it in the proper way. So these are the basics, maybe to make the company work. But for sure, to make a company work, we need mentors, tutors, and we need to identify the right stakeholders. And we have to understand that when we speak about deep tech, we want not the partners to be outside of our world, but we want the people, the partners, the suppliers to be in our value chain, so to be connected. And that's another thing that we have to make it strategically. Looking at the money, the fundraising, we can have two broad things. The first one is the private. So we can look in different ways at private money, depending upon where and when we want the money. But the best thing normally is to look at the smart money. So not only at the amount of money, but at the type of money, the connection that the people can bring us together with the money, the know-how they can bring inside. And the second part is the public. So let me dedicate 5 or 7 minutes to show you where I work. I work for the European Commission, and the European Commission has put, starting from 2021, the 9th framework program that will bring inside the European countries, so the partners, the actors of the research and development and innovation ecosystem of Europe, approximately 95 billion euros divided in 3 main pillars. The excellent science pillars that has got approximately 30 billion, the global challenges and European industrial competitiveness pillar that has got approximately 60 billion, and the innovative Europe that is the main driver of the new innovation of Horizon Europe that brings in these 2 main institutions, the European Innovation Technology, the EIT, and the EIC, the European Innovation Council, where I work. We manage, and so you can consider us, we were born the 1st of April 2021, and we are approximately a startup with a 1.5 billion to invest each year in deep tech projects and companies. How we do it? We do it through the way we want to impact. And why we want to impact? We want to impact because we know that Europe has got what is called the European paradox. It means we have got a very, very high quality, high results driven research ecosystem. But where we are not so strong in Europe is to make the full use, the full exploitation economically and socially of research results. And European Innovation Council want to help overcoming this. And so we are the first executive agency of European Commission managing money content-wise. What does it mean? It means that we are the only executive agency making policy. That means every year we write and put in place, so implement. This is the dual approach of EIC. We write our own work program yearly, and we implement our projects that we fund. But we implement and we fund projects and we work with the projects content-wise. That means we do the traditional European Commission monitoring, but also the content-wise work with. We try to help researchers to make things going to the innovative companies. And we help the innovative companies to go to the market, to scale up. And in doing this, we have this new office, the program manager office, where I work inside the green tech projects. And we are the guys that have to look where some of the money has to be driven. So we identify the challenges that are part of our goals of our work program. And we work hands-on with the projects. We identify commonalities. We help the projects to connect to the relevant stakeholders. And as I'm doing today, we try to enlarge our capability to acknowledge the people that would like to apply to our call. So we work as EIC ambassador. And as an example, to conclude, you can see here an example of business acceleration services that we provide to the different maturity level. Here you see on the right side, Pathfinder Transition Accelerator. These are different funding schemes you can find in our internet site. But you can see that where we help the scientists and entrepreneurs, it is in scaling up, in advising them, in finding the right business partner, and consider that we are the first agency not only giving grants, but we also have a VC fund called EIC fund that can give equity to the companies to give the money. But thanks to the equity, we try to help them in crowding in with other funds. So just to show you what I mean when I speak about deep tech in your field, that is the built environment, just to give you one example of a funded project inside living architecture. In this project, they want to develop living architecture from the side of not only developing the near zero energy building or the zero energy building. So including the renewable energy sources that can be photovoltaics, that can be, for example, building integrated photovoltaics, can be connecting them to the storage of energy and things like this. Not only the energetic system, but this project Lear wants to put in place to use the biology to solve the critical environmental issues of the buildings, and so try to apply the circular approach of using wastes and wastewater to make out of it hydrogen and to use this hydrogen as an energy carrier inside the whole building. So they want to develop what is called the microbial fuel cells, the MFC, and include these microbial fuel cells inside the overall built environment to make use of it, to exploit the biology to be used inside buildings. So to make something that is also called nature-based solutions for the built environment. We are fully acknowledged that the building system is quite a conservative application, quite a conservative field. And so what is needed for this kind of really push approach of projects is to help them in connecting with the relevant stakeholders to understand if and where you can show your technology. So it's important also the prototype develop and the application, as I said before, the testing part. And this is an example of a technology, of deep technologies for green tech buildings. Another one, it's once again a nature-based solution for smart building, looking at the use of biological material, natural materials, in this case as a building material where we can connect sensing and sensors, so we can go in the direction of the environmental intelligence approach of the built environment. That environmental intelligence means, in this case, I use sensors to get the data from the build to understand how to improve the overall quality of the efficiency of the building, but also of the quality of the air of the building. And in this case, so the project is working on using mycelium, that is part of the mushrooms, are the roots of the mushrooms, to be used inside the built environment, inside the materials, as a material that can be part of the structure of the building, but can be used as the source of data to monitor and to improve the quality of life inside the buildings. So these were two existing projects, two ongoing projects, to show you, when I speak about deep tech, multidisciplinary, problem-oriented approach, two examples. The problem is to increase the quality of the living inside the built environment. And the transdisciplinary is the use of biology, combining it with physics, chemistry, and engineering, to use biology, to use the nature-based solutions, and to integrate them, for example, with the ICT, in order to use the combination of the nature-based approach with the digitalization. I hope I was clear. Thank you very much. And if you have questions, I'm still here. Thank you.
Thank you, Dr. Francesco. Actually, this was something personally very big interest of me. I used to work on some European projects, and it's always a very prestigious thing to have a project to perform some advanced innovative research. And it was very useful for everybody, I believe, to get the approach of European Union for any future applications, at least to see what is the expectation of European Union from us, as it is very, very competitive. So thank you again. I have some questions personally, but I think it's not very suitable environment now. Maybe later on I might email you if it is okay for you,
Sure.
just to get some more details. And also, if there is any questions from any of the listeners, please feel free to ask your questions to Dr. Francesco.
I have a question. Could you hear me? My voice is clear or not?
Yes, yes, we can hear.
Okay. So I would like to talk about the last part of your presentation. Actually, You talked about nature and you combined it with the sustainable energy. So as you know, the urbanization is increasing and sustainable energy has like emerged to get like ahead of it. Do you think like this will work in the future? Because as you know, as a human, we destroy the forest and some like part of the like environment, and so because of that, like the population is increasing, and we are trying to like handle it. So it will be in the balance in the future. What do you think about that?
Yeah, that's a very interesting question.
Thank you so much.
I can give you my personal idea, and I think that we are going in a direction where we really need to focus on improving our interaction with the nature. So I think we can learn by the nature a lot of things, but for sure we have to understand that we are the owner of the building that is the earth, but we are part of it. And so I think that to answer your question, I think just to make you two clear examples, as we have seen before, unfortunately, I was not able to follow all the presentation, but there was a presentation on BI, for example, of building integrated photovoltaics. And I strongly believe that we will have to use the most of the buildings to become energy independent. So it is through the photovoltaic, through the geothermal and things like this, but we have to fully use the buildings to make energy in order to avoid to keep on using the fossil fuels, for example, for the heating of the buildings. And this is something that we have to learn, so to better use the sun energy on one side. And on the other side, speaking about critical raw materials, in many energy-related technologies, there is an intense use of critical raw materials. For example, if we look at storage and electrochemical storage, we are fully using lithium, but lithium is not infinite source. So we have to approach the circular approach is not only theoretical, it can be applied, but we have to start, in my opinion, since the beginning to understand which can be the circular approach for the technology we are approaching. So it's called the life cycle thinking since the beginning. So when we design something, we have to clear in mind the carbon footprint of the technology and account, and how can we eventually, for example, recycle on one side critical raw materials, or on the other side, develop technologies that do not use the critical raw materials. This will be hard. It will require many, many years, but on the other side, we also have tools. For example, in the material side, we have the computational materials that can help us in choosing the best materials. These are two examples. I hope I answer to your very difficult question.
Yeah, thank you, Hocam. Like, just I'm interested about that case. I would like to ask it, as you know, like because like we are destroying our environment, and when I say that, I became so sad about my like world, and because of I would like to ask that question. And as you know, like maybe with sustainable energy, maybe we will handle it in the future. Okay, thank you so much. Thank you for answering my question.
You're welcome. It's a pleasure.
Okay, this is actually the end of this session. We listened for different presenters. They were all very nice, very wide area, covering some of them active technologies such as photovoltaic integrated to buildings. Some of them were passive technologies, some of them were adaptable technologies based on the culture and the background of societies. And lastly, we listened to Dr. Francesco giving us very valuable ideas about the European projects. So I will finish the session here, and about 20 minutes later, we will start the new session. We will have 5 speakers in the second session, afternoon session. So Mr. Arif, we can finish the meeting here and continue about 20 minutes later.
Dear Professor, yes, I can finish it the section.
Or alternatively, we can actually keep the meeting ongoing as the time is very short. If you wish, we can do it this way, and 20 minutes later we can continue.
No, continue. We can.
Okay then. So see everybody in the afternoon then. Okay, Good afternoon. I think I fixed the problem now. Second session will start with Dr. Mahmoud Sami Buker. In the afternoon session, we have 6 presenters, and firstly, we will start with Dr. Mahmoud Sami Buker. I just want to give a very brief information about him. He is currently working as assistant professor in Necmettin Erbakan University. He is actively working in the field of renewable energy technologies and performing several projects in this field. He has experience in the field of heating, cooling systems, photovoltaic systems, and numerical experimental analysis on building energy technologies. So I don't need to even have a look at his CV because I know him very well. He is a very successful researcher, and I'm very pleased to have him here today. So Dr. Mahmoud Sami Buker, the word is yours. You can start your presentation.
Hi, thank you, Devrim. Thank you, Dr. Devrim. And this is Mahmoud Sami Buker, an academic from Necmettin Erbakan University in the city of Konya, Turkey. And I've seen my PhD mates and dear colleagues here attending, and thank you for your time once again, for your attendance. As Devrim said, I've done my PhD at the University of Nottingham. My research interest is solar energy, PVTs, thermal collectors, heat pumps, evaporative coolers, solar heating, cooling, and so on. Can I share my screen now?
Yes, please.
Here. Yeah. Today I will be talking about digital twin applications for energy efficiency in existing buildings. The reason why I've chosen this topic is we are working on such renewable and sustainable systems, but now this is the era for the building integration, actually, for the energy efficiency, energy savings, and for the decentralized energy production. So I am also the co-founder of an R&D company here in a technopark in Konya, and we are very active in both national and industrial and international research projects. Lately, what we observe is that we face building information and building energy modeling based digital twins in almost every applications. So it is a hot topic of today's research fields. And therefore, I would like to share it with you. In this context, I will be presenting a brief introduction to digital twin applications for the energy efficiency in the existing buildings for the retrofits approaches. My presentation will not include any research findings yet, but I will try to answer what is it and how it helps. So the construction industry generates almost 40% of the greenhouse gases in Europe, and which is around 40% again in Turkey. So in this case, to reduce this environmental impact and ensure a truly sustainable future, there is a tool called BIM-based digital building information model-based digital twins. So the application of BIM in the evaluation of the retrofit schemes of existing buildings is one of the main research issues of today. So it's a real-time digital replica of a physical object, as both are linked through a building digital twin environment. So basically, we have a physical structure here, real structure, and the replica of a digital replica of that structure of that building. So what we try to do is to create an efficiently the building energy model of the building. So before prototyping, actually, we are studying the systems in the simulation environment. This is what we do, actually, and I would like to show you a paper now, which is using 3D sensors for such applications. So what we do is we try to improve the energy efficiency of the existing buildings and use clean energy. So we try to increase the use of renewable share in the buildings. And also, as I said before, decentralized energy production is the key for today's conventional, the harm of the conventional energy systems, including petroleum and the natural gas, so which is not sustainable. I'm not going to repeat it again. So we know what the problem is. Therefore, so building information management model and the building energy model have profound significance for the development of energy, building integrated energy saving technologies. So we have, so what is a building digital twin? What does it do? Actually, we have, as you can see from the picture below, so we have the real structure on the left and the digital replica of that structure. So whatever you, for instance, if you install solar energy, so you create a solar energy in the same with the same features in the visual part. So why we do it? Because we are trying to achieve ICESBE concept, nearly zero energy building concept. So what we do for that concept, we actually apply passive architectural design. What is it? For instance, we face the building to the south, for instance, to adjust and to increase the solar energy gain. If you want to exploit more solar energy and to maximize the building lighting. So sometimes we use shading and louvers, automatic control of the louvers and the shading measures, etc. And these are all passive architectural design. This is the one pillar of the ICESBE concept. Another one is after passive, we can use active technical measures. What is it? For instance, we can adjust the air tightness of the building. So we can use applications for fresh air heat recovery system. So and also we can play with lighting energy consumption to minimize, so increase the level of, for instance, solar light. And also full use of, we can provide full use of renewable energy, solar energy, building integrated photovoltaics, as we can say, and also wind energy. But the application of wind energy in the buildings level is quite rare. But there are some designs also. So we use these measures to meet the requirements of the technical standard for the nearly zero energy building concept. So next page, this is the sample workflow of a building digital twin application. This is massive work actually, and I adapted this this workflow from the from a very recent paper stated below. So it is, so first we scan the building by using 3D sensors. So we get as much information, as many information as we can. So, and then we just compile this information and use it in the store it in the cloud system. So probably you can guess a lot of disciplines. It is a multidisciplinary study, and a lot of disciplines are included in such studies: software developers, energy engineers, mechanical engineers, and electronics, sensors developers, such that. So, and then in the cloud, we evaluate the data. And then, so we just confine the data to use in the evaluation of ICESBE concept. So, and then in the next pillar, we use building information model. So the existing building that we need to retrofit. So and then for that building, we should define the building energy consumption. So probably electrical side one part and the thermal side another part, and also we need to specify the carbon emissions. So and then we evaluate the system if it is okay. So not this simple, but of course this requires a lot of evaluation process. And then if yes, we apply the model, and then we maybe customize the buildings. I will show you. So how it helps. So we can help. So this approach can help construction professionals make better decisions by visualizing the energy efficiency and carbon emission. For instance, HVAC system, heating, ventilation, and air conditioning. Probably these standards, maybe everyone's standard is different. For instance, I like 24 degree and someone else 23 degree, 20 degree, for instance. So by with the building commissioners, by using you can demand and you can customize the heating, ventilation, and air conditioning system for you. So it can improve the collaborative workflows, even in the erecting the building. So in the construction phase. It can reduce cost because energy saving, and it can also affect usability and comfort. Even it can predict upcoming events. For instance, when is your heating, ventilation, air conditioning system requires maintenance. So this is basically my presentation. Thank you very much for your patience and sorry for being late. Actually, I was in another conference since the morning, so I jumped into this one. Thank you very much, and thank you for inviting me.
Thank you, Dr. Sami, for this presentation. It's a new perspective for the scientific research in building energy technologies, I believe. Normally, we mainly focus on some specific technologies, such as photovoltaics, thermal storage, cooling, heating, etc. However, I think the new era is somehow combining them in the most optimized way and controlling them, integrating them. I think this is the direction. Also in the previous presentation, as Dr. Mateoji mentioned, the European Union is expecting this as well. So mimicking the environment, somehow integrating computer engineering, computational science, thermal science, electricity, all of them together. And I think this is the new perspective for doing an advanced research. Otherwise, just an individual testing in the lab will not be sufficient, I believe, from now on.
Definitely, yeah.
Okay, thanks a lot. I would like to ask to the listeners if they have any questions in their mind regarding to this approach. Please feel free to ask your questions to Dr. Sami. Any questions? Okay, thank you. I think we can move to the next presenter because we have a tight time schedule. I just want to thank again to Dr. Sami, and it was very, very nice to see you again after a long time.
Thank you, Dr. Dev.
Thanks for your contribution.
Thank you for inviting. Thanks a lot. Thank you for your patience and thank you for your time.
Thank you. Okay, so we can move to the next presenter, Dr. Melissa Yakuch. I think he graduated in computer systems education in 2005 from Sparta University of Applied Sciences. Then he completed his PhD in the same university in the field of mechanical engineering. And he has experience in the renewable energy technologies, applications, and I think he will do a presentation today regarding the use of hydrogen in the building energy systems. So
Yes.
I would like to give the word to you, Dr. Zia.
Yes. Thank you very much, Mr. Devrim. And I'm very happy with you, and good afternoon to everyone. And thank you for listening to this conference. I am so happy with you. And today I will give I will present our team's new project, and we start a new green hydrogen systems. And so we prepare a project also about this subject. And today my presentation about the evolution of the green hydrogen as a sustainable energy systems for the near future. And here is the our teams. And now you know the hydrogen is an energy carrier and not a source of energy. So this is not a new technology. The hydrogen is using a long time, and in some of the industrial. And today, the hydrogen is the really important things for the big energy sources. This energy sources comes from the clean and sustainable. And so hydrogen is a really and nice and good options for the net zero emission aim. And also the hydrogen, the key driver decarbonizations for the industry. Now, and so the hydrogen is also produced from a wide variety of the energy sources. And it's also predominantly produced from the fossil sources nowadays. But the many new research topics and research subjects about these problems. And nowadays there is a lot of the new renewable energy sources, hydrogen systems, and also it is development the new opportunities. And the hydrogen is a new pathways to valorize the renewable energy sources. And also it is becoming cleaner, but nowadays it's a bit walking slowly. And so today's the hydrogens express different colors. So you can see that. And many different names also. And also this is a bit problems for the peoples. They can't understood what's the meaning of these colors. So another important things except the colors, it's how it's working for the footprint of the carbon. And for this reason, there is another scale of the hydrogen systems carbon emissions. How is the results? And today there is a lot of different sources how the hydrogen productions. Hydrogen systems, but nowadays we are focusing on the green hydrogens. Green colors comes from the renewable powers. For this reason, it's more important than the other systems. And so the carbon intensity, I say very important. For this reason, it opened the debate about the competitions between the various hydrogen production routes that meet the required carbon intensity at the least costs. And so the green hydrogen is so popular, and our project is also made from the solar systems and the hydrogen systems together. And this is the real fantastic things for the energy systems. And so nowadays there is a lot of name. It's really mixed things for this systems description. So especially in the Europe, they are changing this mistakes classifications. They want to make a more simple and also clear identity of these systems. So they are also classified with the carbon footprints, and we will see that how it's going at the future. And here is the hydrogen demand and the production sources. We are so sorry, but the reality is here, and the big part of the hydrogen production systems, and they are still using the oil and coal. And another big groups is the natural gases, but nowadays they are a little part of the these systems, only the renewable systems or electrolyzer systems. So the hydrogen is widely used in the several industry sectors, with the vast majority of its being produced from the natural gas. You can see also this figure, and for this reason, we need to change these ratios for the next clean days. And here is the how can we use the hydrogen systems using the electrolyzer with the renewable systems. There is a lot of process also, and there is a lot of options for the systems, how it's made. And the mobility part is also so popular nowadays that there is a lot of the alternative models, the fuel cell electrical vehicles, and its name is the FCEV. And these cars or these vehicles are so popular, but there is also some problems for the sustainable using. So I think it will be solved some major problems next years, and we will see the more important projects about this subject. And the heat systems also another popular things. And the last one is the reconversions using with hydrogen can also be used to regenerate electricity, and this is also interesting. Here is the hydrogen demand for the 2030 and 2050, and you know nowadays we are so important days we lived about the climate crisis topics, and now you know a great conference at the Scotland, at the United Kingdom about COP21 names, and there is a very important decisions takes. And so this topics also is so important for the major view of the world's energy politics, and the demand of the hydrogen stood at the 19 megaton in 2020, and practically all for refining and industrial applications, and produce it almost exclusively from the fossil fuels, resulting in the close to 900 megatons of the carbon dioxide emissions. So we need more strategies and more politics, because there is a big gap for field. The scenarios is not realistic sometimes. So we should make realistic projects more. We have to make. Otherwise, there is a really we can really big problems on the climate crisis. We are at the crossroads for these problems, and the net zero emissions scenarios sometimes really dramatically, and the pessimistic scenarios are too much. And but I know if we have to make something on the science part, and we use the yes, 40% in 2050, and to issue the decarbonized energy growth envisaged by the agreements. And the next is the electricity generation with the green hydrogen use. The green hydrogen, which is produced from the renewable energies in a climate-friendly way, opens up completely new possibilities for employing renewable energies in areas which still emit large amounts of climate-damaging carbon dioxide. And there are different methods available to generate the hydrogen. One is the electrolyzers, which produce climate-friendly green hydrogen. And the electrolyzers, there is a important part of the systems. There is four different technologies, electrolyzers for the waters, and the electrolyzer. The one is the alkaline, the second one is the proton exchange member. It's also so popular and also more efficiently. The third one is the solid oxide electrolyzer cells, and the last is the anion exchange membrane system. And so you can see the figures, and which is the better or which is the worse. And the most important things, what you want your projects. So for this reason, nowadays the PEM is so popular on these systems. And here is the typical system design with the PEM electrolyzers and how it's work. You can see, and here is the our project. It's near to Golden Horn in Istanbul, Haliç center, meeting center, near the Haliç meeting center. We have one solar collector, vacuum tuber, and we use this solar collector, and after we have one PEM electrolyzer, and there is a one tank and heat exchanger we use. And we hope in the study is to determine the parameters that affect the performance of the clean and sustainable hydrogen production system by considering in terms of the thermodynamics. And the main purpose of this system study is the evaluate and experimental the performance of a clean and sustainable hydrogen production system. Next is the future policy of the hydrogen. Yes, I said before, there is some barriers on these topics, but the scientists and the science ready for solve these problems. But the scientists needs the more support about these problems. How can we solve? Otherwise, there is no alternative systems for the near future. And here is some barriers and the policy options in these figures. With the role of the hydrogen in the energy system still to be resolved, the governments are currently focused on the understanding where hydrogen might be useful in their energy transitions. Yes, it's so important, but last year, many of countries declared the hydrogen outlooks of the countries, own countries, and so there is one little hope, but I'm still not sure because when we have the COP26 meetings, sometimes we feel the pessimistic things, and I want to hope for the near futures, but it cannot be easy and it cannot be fast. Maybe next days we can see the maybe more optimistic things. But I am not still sure. And thank you very much for listening to me.
Thank you, Dr. Melik Ziya, for the presentation about organic Rankine cycles and hydrogen production. It's a really important field in the building applications or industrial applications as well. The project also seems to going very well. I hope you get very, very good results because it's something very important. I'm imagining in one day, if we have such systems in buildings, something like a compact unit, which could produce electricity, hydrogen together, making the building self-sufficient. It would be a really good opportunity for us. Thank you for the general information on hydrogen systems and also about the technology. So we can move to the new speaker, Dr. Meltem Vatan. Dr. Meltem Vatan is faculty member in Bahçeşehir University, Faculty of Architecture. She gained her BSc, MSc, and PhD degrees from Yıldız Technical University. So I'm very happy because I'm also graduated from this university, my undergraduate and master's. So she will be with us with her presentation now. I can give the word to you, Dr. Meltem.
Hello, everyone. First, I would like to thank for the invitation and for this very nice organization. I wish to be face-to-face like we did before. Maybe in the next time we will be, but it's very good to see everyone, although in the online session. So I think I can share my screen. So can you see my screen?
I think it is on the way. Yes, we can see now.
Okay. Okay, I admitted someone anyway. Okay. So today I am going to present adaptive reuse of historic buildings with a case study of Gaziantep Governorate building. Actually, this is an ongoing study where my colleague Feyza Akuyucu, her name is written here, She is part of the academic staff of Gaziantep University. Also, she is my classmate from our undergraduate time, let's say. And still we are working together more than 20 years actually. So this is an ongoing study, as I said, where we try to raise the discussion about the historic buildings, the way of their preservation, and for sure, because the life itself is an alive issue, we cannot preserve the buildings exactly in their state as they were constructed for. So we need to adapt these buildings to the new lifestyle. And this study of Gaziantep Governorate building has a restoration process where the new function was given to the building. So I will try to raise the point about this reuse issue and what is the part of this study that still be ongoing, we work on it. We try to finish our interviews with the people who knows the building before, and then how they use or how they feel the building with its new function. So maybe in next time I could present the results of this research. So that's why for today I will be more speaking about why adaptive reuse. And actually here I would like to say that maybe the point of view of architecture is rather different than the one from the engineering point in terms of energy consumption or sustainability or ecology or resilience. These are the keywords that mostly we use for the energy and how to use the new energy resources which are more environmental friendly. So why adaptive reuse? Because we may design, we can work on a future is the possible one for the next generations with different options. We may work in a way where we will have the existing energy resources, which for sure will be ended maybe sooner than the one which is predicted. And then we will have some failures, we will have crises, not only for the point of view of the energy, but also for the economy, for the pollution to the environment, for the social life, for the human soul, for the life itself. Or we may think about some other energy resources that actually this conference is more concentrated on them, where we can use the other environmental friendly energy resources types, and we may say that actually they do not end comparatively to the ones that we have as limited resources today. So maybe you can ask a question, how can we make a relation between preservation of historical buildings and to speak about the consumption of energy or to reduce the energy use. So this is exactly the topic that I choose for today, how we can deal with this subject. Actually, when we think about the construction of the building, doesn't matter the historical or a recent one, the contemporary one, actually the consumption of the energy for the buildings start before they start to their service life, which means mostly we are thinking about and we try to reduce the energy which is called as embedded energy, the energy that we use before start to use the building itself. How we use some energy before buildings start to service its service life or its function, because mostly when we say that we consume energy, we think in a way that we heat the building, we cool the building, we heat the water, we need to manage the internal climate. So for all these reasons, we have to use the consumption of the energy. However, when we have a step back, also we have the use of a lot of amount of energy depending on the scale of the building, even before all these services of the function. Like when we start the construction of any building, we need to bring some material to the site. We need to excavate the site to raise the building itself. So for all these reasons, these are only the small part of the energy use that we need to have. When we bring any stuff, any material to the site, we need to use the modern life technology, which means we need to use some vehicles, some construction machines, so we need to use the energy. Even to put some water into the mixture of the cement, we need to use the natural resources. So how we can reduce the energy even in this very beginning step is one of our considerations, in particular when we have large-scale buildings, like to use the local materials, like to use recycled materials, to use natural rainwater, for example, are the small steps. But when we consider the building industry, which is like 70% of the whole industry, so it's a huge number, we can say that we have a consideration about the consumption of the energy even before the functional service of the building. So this is the small part, just as an introduction to raise your attention, to take your attention to the way how we think about the energy may be rather different than the approach of the engineers. And then when we come back to the adaptive reuse, which is a terminology related to the historic buildings and the way of their preservation, actually adaptive reuse is the way of preserving historical buildings by giving them a contemporary use, which means to reintegrate the buildings into the modern life, into the context of their new place, the new city, or the new environment, the new neighborhood. Here, the new doesn't mean to relocate them. The new means the life which is itself is changing because of its because of being alive itself. So in this way, why we consider all these issues? Because we try to extend the life of the building. As I started to my words with the construction issues, and when we even construct the building, when we first start to use the building, how a huge amount of the energy is consumed, we can easily consider that to extend the life of the buildings also has a positive effect on the consumption of the energy in terms of its reduction. In this sense, we try to reuse, we try to extend the life of the buildings. This terminology or this concern started to be discussed in the 60s and 70s. So this is quite a long topic for architecture. And it is related for sure with the high speed of the development of the industry, of the technology, and for sure with the increase of the population which live in the cities. And for sure, we need to have more buildings, we need to have more people in the cities because of the change of the life. So somehow we need to make a decision about the intervention to the buildings in terms of their reuse and their new functions. However, when the issue is historic building, also we have some other cursors, even we have some strict limits, in which sense we need to protect the originality and the authenticity of the building. We cannot change too much, we cannot intervene the building too much, because we need to protect its historic value. So this is the hard part for the reuse of historic buildings. That's why we call it as adaptive reuse. We need to adapt to the new life, but also we need to consider its function itself and the originality of the building itself. So for this reason, how is the approach of the adaptive reuse for historic building? First of all, we try to add a new contemporary layer, a new contemporary life to the existing historic building. Here we have some strict concerns in a way that we need to consider the building capacity in different senses, like the building capacity itself for being able to be used. The other one is its load-bearing capacity. So we cannot load the building more than the one that it was constructed for. That's why this task actually it's a very challenging one, because there are different parameters that we need to consider. So we need to consider the physical characteristic, the potential of the heritage building. We need to analyze the building in a holistic way, and then we need to find the best solution for its integration to the modern or to the contemporary life. And when we do this, what we can achieve, or what would be the positive effect to the environment and to the architecture, to the buildings, to the humanity itself. We may save the abandoned buildings, and we can have the new assignment for them as the new function. So we can preserve the buildings, and also in the other hand, we can preserve the intangible part, which is the community and its culture. By giving the new function, we can also give the option to the community and its neighborhood to adopt their life, both in contemporary way and also by preserving their historic ways. So we may also limit the migration from the rural areas or from the historic areas to the modern cities, which is mostly the intention because of some economic and other reasons for the new life, or contemporary life, excuse me. So we may give a new direction to the region or to the community, to the place where they have their historic buildings and their historic values. So when we consider the adaptive reuse, which also takes part within the resilient cities approach, because you know that in resilient cities approach also we have the consideration of the use of the resources of the city in its limit and to increase its capacity. So we have in one side adaptive resilience, which leads us, or which has a part of adaptive reuse. And then when we reach to these targets, let's say, we can have an urban resilience strategy, or we may have part of the urban resilience strategy. We need to have firstly an adaptive cycle. We will see what exactly we means with this. And we need to use the existing infrastructure, but also we need to try to extend its capacity. So what does it mean for us, adaptive reuse cycle, and how it can take place within the resilient cities approach? Actually, in the traditional way, we have a construction, like we say, the birth of the building. Then it starts to grow, which means we start to use the building. And as the human life, it became older and it released, and it is under the underuse, disuse, which means we demolish the building. Depending on the structural system and material, the service life of the building might change. It might be like 50 years, 70 years, 100 years, whatever, but it is a limited process. Although for historic buildings, because we protect them, they live for more than 100 years. And then we start to renew the buildings, or we start to build the new buildings. In traditional way, we demolish the building when they ended up with their service life, and we construct the new one. However, when we have the adaptive reuse approach, we renew the building in terms of change of their function. So we help to the cycle in which part, in the use part, between the use and the ending of the life of the service of the building, we add some new two issues, like when the building is under the use, then when it starts to be disused, so when it starts to go down, let's say in its service life, before it is demolished or abandoned, or before there are some severe damages on the building, we can consider adaptive reuse, and then we can turn back the building to its use. So by this way, we can protect the buildings. This is also the approach for the sustainable approach of the design and architecture, by the way. So that's why, as I think everyone is aware of sustainable development goals, SDGs, that we have 17 of them. You know that in 2015, it was an agreement among different countries where our country put a signature as well. We have some different types of the sustainable development goals. They are not only related to the energy or to the architecture, to the engineering side, but also they have a social lifestyle. So within them, we have the consideration of the people with low income, the people who doesn't have even any food to increase their life quality and life capacity. But as an architect, as a person who is working on the field of architecture and historic heritage, the most goal that we are interested in, or that we work on it, is the number 11, where we have sustainable cities and sustainable communities. As you know, we have a lot of subtopics within each sustainable development goal. Just I put the big picture of all of them, and just I want to mention that we are mostly concentrated on number 11 and its subtitles as well. So when we have the adaptive reuse approach for what we can help, actually we have a lot of aspects, like about the environment, the social life, economy, where all of them intersect with the sustainability. So we need to consider the social environment as the intersection of environment and social part. We can consider environmental economy, which is also important because, you know, each step has its own budget. And also we need to consider economy and the social life, again, because each step has its own budget, let's say. So we cannot consider any step without consideration of the economy, in particular when we deal with the subject of the energy. So here I just wanted to put the aim of sustainable development. I'm not going to read for sure, where to explain that actually we have the consideration basically about environment, economy, and social life, and they have their intersection, and at the end, the intersection of all of them is sustainability itself. So what about our case study, or what is the point of our view for the case study? I see that I have 5 minutes, so I will speed up. Our case study is the building of Governorate of Gaziantep city. So here we have the map of Gaziantep city. This is the old castle of the city, and then in surrounding the new buildings, the modern life surrounds the old or historic part of the city. Here we have the site plan of Governorate building, just to show why it is important. It is located in Republic Square, which is adjacent to the one of the main axes of the city, as Hürriyet Street and Mecit Barlas Street. And in that picture, Republic Square is in the north part of the building. Here we have some views from the building, the night view and the entrance of the building. This building is integrated visually and functionally with the Republic Square. That's why it is one of the landmarks of the city. It's a symbol of the city. Also, it has an integration in terms of the architectural design with the Atatürk statue, Hürriyet Avenue, and for sure, as I said, it is located along the transportation axis, which is very important for the city. So still, that's why this building is important for the city. When we look at the data which is related to the building, we can see traces about the building, like its construction is dated back to 50s. And obviously we can see the modular design, which is very typical for this kind of buildings. And the material is reinforced concrete, and the structural system is a frame system. You can see easily the repetitive manner of the rhythm on the facade of the building. So to preserve this building, for sure, if you consider the function of the building, which is a governorate building, for today, its capacity is not enough to serve. But the building is part of the history of architecture for that city and for the Republic history, by the way. So we need to preserve this building. And for this preservation, in 2014, there is a decision to change the function to a culture and art center. So here we have some pictures before the restoration process in the original way. And here we have the pictures after the restoration process. So we can see how the building has been changed in a way to be an art and culture center for sure. So after this explanation, what I can say as a conclusion, although the study is a continuous one, ongoing study, for being able to remember the past, we need to dedicate ourselves to the future. This is very important. And to preserve the heritage for the future, it is very important because the heritage is an anchorage to the place, to the community, and it is the memory for the community. So it gathers people together. So the heritage is a record for posterity. We can have the information about our ancestors. Its adaptation to the contemporary life and to have the service about its needs is one of the practical tools for the preservation and extended service life. And adaptive reuse provides this integrity with the historical heritage and the new life requirements, let's say. By this way, we can reduce the energy consumption for demolishing the old buildings and for construction of new buildings for any case, but for historical buildings, we don't have any option to demolish them because they are our values of our culture and our history. So that's all. Thank you.
I would like to thank Dr. Meltem Vatan for her presentation in the field of adaptive systems of buildings and adaptive approaches. So if you have any questions, please feel free to ask to Dr. Meltem. Any questions from listeners? Okay, I think there is no question for the time being. Then we can move to the next speaker, who is Professor Dr. Miguel Moreira Pinto. Professor Miguel got his BSc degree in architecture from the Lusíada University in Portugal, and later he completed his PhD degree in history in Portugal again. He has both teaching experience and also project experiences in the field of architecture. And I think this experience would be very useful, beneficial for all of us listening to him today. He will give us a presentation entitled "The Energy of Visual Communication." Thank you, Professor Miguel. I will give the word to you. You can start your presentation.
Thank you for, first of all, thank you for this invitation to make part of this conference. And also I'd like to, let's say that I'm very happy to repeat and to be here and to be, let's say, to be joined to whole of this team and with all my Turkish friends and colleagues. This is very important for me because it's a very powerful link that I have in my professional life and even in my private life. So this is really an important moment. It's always an important moment to participate in this conference or in other subjects linked with the Turkish people. So for that, thank you to all of you. And well, about my presentation, as always, maybe I'm like a little of an outsider from, well, from this team. and sometimes it's quite complicated to discover or to describe also what I'm doing, because when I talk about communication, I talk about the power of communication. So the way how we communicate in general. And when I'm teaching to my students, I always try to improve them the mood, how to talk with the client, how to sell the project, or how to do the project itself in such a way that it looks good for the client, and in somehow that can explain the idea and the concept that they are doing in architecture, of course. So about colors, maybe I will share the PowerPoint. Otherwise, I will talk and talk, and I will forget to share it. Just a second. Can you see it? Yes? Okay. So when we are talking about communication, and I always link to the idea of colors, because colors really improve our mood somehow, and at the same time they can, let's say, catch the attention of people for what we are doing. And colors are very important. I'm not going to talk about architecture or any subject, let's say, linked with colors. I'm just talking about the meaning and the concept of colors. So my presentation is more about the importance of the using of colors. And all of this started by a book that I read it in the past. The name is ABC from Bauhaus, from Ellen Lupton. And Ellen Lupton wrote on her book the meaning of colors by the experience done by Kandinsky during the Second World War. So Kandinsky, as you know, it's a very well-known painter, and he was an abstract painter. And when he was inside of Bauhaus, it was like an art school from that time, a very important art school that trained people to do, let's say, different ways of expression in the point of view of art, in all fields of art. And Kandinsky was very curious about the meaning of colors, because if you imagine on that time, the paintings, there was very figurative. So imagine if you find 4 or 5 artists that started to painting abstract drawings, abstract paintings, you know. So people was like, some people was fascinated, and others, they was completely crazy, saying that it was not art what they was doing. So Kandinsky tried to prove that it was art in somehow, but because art is not a science, he tried to make a survey asking people about the meaning of colors. So what the red means, what the green means, etc. And then he linked the meaning of colors to the meaning of shapes. So like a square, what it means, a triangle, what it means, etc. So he have done this survey, and after all of these years, almost 100 years later, I decided to copy his survey and try to understand if people nowadays are still thinking about the same. So my presentation is more about that. It's about the curiosity, about communication, and about understanding. So we are not just talking about a brand, because colors are always, or much more often, linked to brands, but we are also talking about communication, about psychology of colors. So how we can interact with colors and how colors interact with us. I'm not going to talk about what it is written in so many books. I'm going just to talk about experiences, about ideas, okay? And what I want is just to open and, let's say, retrieve this subject for all of us, because colors we use in our PowerPoint presentations, we use in our houses, in our cars, and sometimes we don't see the colors. So that's the idea. So it's to talk about the importance of colors. And as you can see here, you have a few places where colors are used, you see, an abstract painting, in flowers, in culture. So in many places we can use colors, and we feel fascinated for them for almost always. So I have done a survey, as I told you, and in general, it's very interesting because in 2010, we researched it and we make this survey to 180 persons. Just, it was not so much people, but it was just to have an idea. And just for you to know, at this moment we are increasing this research with more colors. So we started this research just with the main three colors, the yellow, the red, and the blue. And of course, because we have done the research to grown-up people, we discovered what it was obviously. When we asked about the most happiest color, moreover, all of the participants on the inquiry, they said that 66% of people, they decided to say that yellow is the most happiest color and the blue the most sad. When we are talking about sad, it's not that we can cry because we see the blue. It's just because it's not so shining. So it's because of that. But what is more important in this survey, I don't have here the graphic, is that when we have done this survey to 50 children, and you know that children, they don't lie, and we ask about the what color is more happy. You know, some children said that it is the brown, others they said that it is the pink. So it doesn't matter in reality what it is the most happiest color, but what we can understand is that how much more shining, how much more lighty is the color, much more happy is for the person. Of course, at the same time, when we ask to the people, for example, a triangle, it's a very calm and quiet shape, or it is a, let's say, it can cause some kind of stress to you, or it is aggressive. And in the majority of people, they said that triangle is very aggressive, for example. And of course, if we think about triangle, square, and circle, they said that the circle is the most soft, the square it's the most strong, and the triangle the most aggressive. Okay, so if the triangle is the most aggressive, then what color should have the triangle? And it seems that it is crazy, but people, the majority of people, like 80 or 90% of people, they decided to put the yellow on the triangle. So if the yellow is happy, why they put the yellow in something that it is aggressive? Well, it's because yellow, it's not so happy, because someone teach them during the school that yellow is the sun, yellow is a happy color, but it isn't in reality, because yellow, it's very aggressive because it's too shining. So it causes some kind of irritation. That's why they linked the yellow, for example, to the triangle. You see, so it seems that sometimes we learn about colors because we learn by the book, and by the book, we are not learning about by emotions. We are learning about what someone researched and said, and everyone accepted like if it is true, you know. So in somehow, yellow, it's happy, okay, because it's shining, but it's also irritating. So it's aggressive. That's why they linked to the triangle. So when I'm talking about this, it seems this is very simple, but this is very important, because when we are doing our, let's say, decoration, interior design of our houses, or when we are doing just a simple PowerPoint, for example, we need to think about what kind of colors we are using to catch the attention of people, you know. So colors can have the power of decision. This is very important. You have here a picture of my ugly face, you know, trying to show that I'm trying to decide something, and it's only black and white. So it seems like something, let's say, with a cultural high standard. Like it seems that have quality just because it's black and white, because it's empty of colors. But then on the next picture, you have also grayscale, so it's like black and white, but we have done a blue background. We could put other color. We decide here for this presentation to put in blue. And of course, we create a contrast. So we create a story and people have something to say about it, you see, but colors have the power to show the image or to show what we want to communicate. So background is like a contrast. And this is very important because even when we are doing this PowerPoint presentation, we need to think about not only about the words that we want to put in our presentation, but also about the energy that colors send to us, that they give to us. And in that way, we can catch the attention of people and try to improve also the mood of the persons about the subject that we are trying to talk about. Or when we are painting a wall in the shop, for example, we need to show that in that specific place of the shop, we are, for example, with sales, you know, so they put different colors because they want that the clients, they look to that place. This is important. Everyone knows about that. We know that it is easy to understand, but in reality, you know, it's not so, let's say, so easy because we must think about the way how we can interact with people. So colors can boost our mood. This is something that it is obvious, you know. And when we talk about red, it's very funny because we linked red to love, for example, but red is really a powerful color. For example, here one more time, I decided to choose black and white photos, you know. And for example, on the first one, I'm trying to show the feeling of emptiness, you know, and I only have something on my head, my hand, but that thing that I have on my hand is red. So our eyes goes and links directly to the red color. So for example, if I want to sell a product or if I want to show something very special, I will put the first moment of our seeing on this red spot in the middle of this big rectangle with gray scale, you know. Or for example, on the other one, I'm trying to explain that you can press something to start dreaming. So it's like the color gives you an input for imagination that makes you dream. And how the colors can make you dream? Of course, you can read the book and you can say, oh, scientists, they say that red means this and yellow means that. But no, in reality, it's not like that. For example, you have colors that you feel attraction, and sometimes you feel attraction just because you imagine that on that day it was something very good that happened to you, and you feel that that color gives you lucky, for example. So it means that in important days you use that colors. I'm just thinking about, for example, in Japan, if you will use orange color in Japan, it's almost always linked to happiness, you know, for good luck. So people say that in Japan, okay, if you are wearing something with orange color, it means that I will be lucky on that day, you see. But it don't mean that for you, you can, well, something very bad could happen on that day and you was dressed with orange. So for you, from the next days, if you will wear orange, your memory will tell you that it was a bad day, so it's better to don't use because you don't feel well. So what I'm trying to explain is that colors have always a link with our emotions, but in general, they are linked with our cultural past experience, and this is very important. So it don't mean that people who look to the red, they feel the same to the red, because, well, it means that you have a past experience and for sure you have an opinion about the color, and that's the way how we should behave to interact with the colors. So colors express ideas and feelings, you know. Colors affect human behavior and responses, because it's like this. I can, for example, on this painting, I use the yellow, you know, and you can see, wow, what a nice painting. But if you can see, I decided to put a background on my slide that it is a dark gray background, just to show the yellow color like an important point where you should look in my presentation. And well, this is to create contrast. And I created that because even if you think that it is a very ugly painting, and it is, okay, but for your mood, it causes some good mood because you are more relaxed during my presentation because you looked to the color and you catch, and I can catch your attention because of that. So imagine in your houses, in your offices, in your life, you can use like this. It's like when we are in the middle of the car traffic and all cars are almost gray or black or white, and in the middle you can see, for example, a yellow car. Everyone will notice there. So it started to be a reference of that day, and in your memories, in the end of the day, you will remember that car. It doesn't matter if it was a very ugly car or a very nice car for you, but you remember for sure that somehow a yellow car crossed in the middle of all of that dark cars. So it was like a reference of the day. So you can be noticed in the middle of this. So colors can interact in a way that can help you to sell the product. When I'm talking about a product, I'm not just talking about design or a brand. The product is also the way how you communicate. It's what we want to say. I'm using a lot of yellow in this presentation, not because it's a happy color, but because it's a color that in general catch very well with the gray color from my background of the presentation, okay? So it can help to sell the product. It's also, let's say, captivate for your perception, you know? So it means that your perception feels not relaxed, because the yellow don't gives you the feeling of relaxation, but it can helps you to put people looking to that place, you know? So memories and experiences are always linked to our to the meaning of colors, and also about the meanings of shapes. So colors can help very, very much in the way how we make the communication. And of course, the powerful of colors in the point of view of energy, you know. So imagine if the colors are also linked to artistic things, to artistic, let's say, performances, for example, we can improve the spirit of the street. But also, at the same time, as you can see in this picture on the left side, they decided to paint the walls. This is a very well-known picture, but at the same time, imagine that you need to live there. So this is good for a moment, but at the same time, it creates like a visual pollution, you know. So it's not such a big sustainable, let's say, perception that we have about the street. So it's a happy moment. So it's linked to connect and to talk with us for a moment, improve our mood, can make us, for example, spend money on the shops of that street, or can make us go there to take pictures, and then we can upload the pictures in our Instagram. We will have a lot of likes, you know, so it's good for our communication with the others to show that we was there. It's also good for the city, because the city use this kind of streets because people put in the Instagram for free. So it means that we are making advertising, we are spreading the name of the city for all over the world. More people would like to go there to visit that place and take more pictures. So it's like a free way to make advertising about the city. So the city name, it's spread along the world, because in our social network, everyone take pictures of this. Some people because they really like, others they don't like, but it don't means nothing. Just means that people go there because it catch the attention of people. So colors are very often linked to art moments. And here we have another idea about the use of colors. It's like the video mapping, that it is very fashionable nowadays. So it's a way to interact with, in general, with heritage and with the urban scenario. So urban scenario, for the first time, a city or a street or a building can be linked with virtual reality. So it means that the virtual reality of this moment of colors and shapes are living together with the real world. So it means that virtual reality in this case doesn't exist if they don't have the urban scenario. So people can interact, they can live an experience in a big scale, but at the same time we can change the, let's say, the layout of the city, the layout of the building, without being so much expensive. We don't need to paint, but we can interact with people in the street, and people can feel happy or sad or even stressed, because this kind of shows also cause stress. But it's a different way to interact with people between the virtual reality and also between the urban scenario. So it's a modern way, but also they use the opposite colors are very helpful to increase the power of the communication. So there are some cases and some situations where we think that why I'm going to use opposite colors, like for example green and red, and people say no, green and red, they are terrible to link together. But no, in reality people say that because they are not comfortable to wear that kind of colors. But if we use, they really link because they come from the opposite sides. So as you know, when we are talking about the three dimensions of colors, the opposite sides, they touch on the other side. So they are really well linked, and we can improve the spirit of the place and catch even more the attention of people, and we can make, let's say, new designs of communication. And I found this picture in the internet about the meaning of colors and the colors that men and women most liked. And well, in general, we can see that everyone likes more or less the same colors, but in different percentages. You see, for example, the purple, I believe that it is more cultural, but the purple, for example, the men's, they say that they don't like, you know, but women, 23% of women, they say that they like. But for example, if you go to the red, men like 7%, women like 9%. So it's nothing special. The differences are almost nothing. So it means that the gender is not so important for, let's say, not for the meaning of colors, but if we like or not about the specific colors. Just sometimes men, they are shy to say that they like pink, and women, maybe they are also shy. Well, women in general, they are not so shy, but well, because in a cultural point of view, someone teach us that the pink is for women and the blue is for men, and that's it. But in general, the colors don't have a specific let's say, decision or taste depending the gender. So I'm almost in the end. But when we talk about abstract colors in our life, you can see, for example, this picture full of electrical cables, you know, electrical lines, and then a painting, it's also abstract. But again, and one more time, the importance of color is so important that it seems that these electrical cables inside of this package, it's like a sculpture, it's like also art. It seems that communicate with us. And with the painting, we also can say that communicated with us sometimes, and for the majority of people, they don't like so much the abstract because they don't understand what it means. But our brain need to understand. So because I put these two pictures here, I can say that if I don't know from where it starts, this abstract painting, I can say, okay, this abstract came from this picture on the left side. So it means that it is a resume about the colors from the other side. Okay, so I can understand abstract because our mood need to understand something real in the abstract world.
Professor Miguel, if you can summarize in a few minutes because we exceed the time.
Yes, it's just one slide more. So the colors can change the idea how we see and how we can interact. That's what I told. But we also put movement in our, let's say, in our colors, we also it gives more attention for a specific place of what we want to show or communicate. So this is what I talk about. So it's not necessarily nothing more. And just to finish, okay, we need to be very careful because the energy around you can affect your health too. And colors are in the middle of these. So thank you for your attention. And I'm sorry because I spent a little more time than it was necessary, you know. Thank you very much.
Thank you, Professor, for the nice presentation, especially for the ones like us engineers who are just filling their minds with physics, maths, engineering problems. It was a very different perspective. Sometimes we are missing this art approaches in our lives, which has very high importance in our emotions, affecting us in many ways. It was very interesting, very nice. Thank you for the nice presentation again.
Thank you, me.
So if you have any questions to Professor, please feel free to ask. Otherwise, we can move to the next speaker. Any questions?
Hocam, actually, like, I don't want to get like more time of you because I have some questions. I will be a little bit fast because like I really like interested about some cases. So let me ask that questions. First of all, I did like some research about like golden ratio and the effects of like colors on people before. My question is about like, do you think people use in workplaces or in important companies like that like effect of the colors? Because like I have like read something before, like for example, blue color gives a peace and like trust to people. And to be honest, like I tried and it has worked before. So what do you think about that? Because it is so sensible, actually.
Yes, thank you for that question. Well, about the survey that I have done, it's really about that. Here, it was just a very short resume about the meaning of colors. But what I was trying to say in this presentation is that what it is written in the books, or well, the opinion by the books, it's in my opinion, old opinion. It was like an opinion that comes from the past. Nowadays, we live by, let's say, storytelling, and by the way, how we communicate, it's to create atmospheres. And those atmospheres, like nowadays, and our culture, our modern culture of nowadays, we live in the middle of atmospheres, and we are not so linked about the opinion of others, the opinion of what it is wrote on the books, but by our own experience. So the way how I interpret the colors, it comes from inside of me and not from the book. Of course, for design and what you are talking about the blue, it's not the most happiest color for sure. And in my research, it's even the color that people choose less. But if you will look to our pictures here, almost all of us, we are wearing something blue. And we wear blue because we accept it blue, because it don't means absolutely nothing, not calm or not relaxed. It's just because it don't mean nothing. And because it don't mean nothing, we can use it because we know that we don't need to catch the attention of others. So that's why. And even the yellow, as I told, the yellow, it's a very lighty color because it's very shining. So it's good to catch the attention. But also, if you see in the street, it's not so many people who wear a yellow shirt, for example. But if they will wear, it means that they want to communicate, they want to show that they are there. So they want that people look to them, you know. So colors really improve the mood. And when you talked about the golden
It's not our
proportion,
topic actually, just like I would like to mention because like I did some research about that. And also I have another also question, and the last question. Sorry for the taking your time actually. I know there are like many like presenter also. Like Hocam, I would like to, sir, sorry. I would like to talk about like also about the colors. You told like, for example, about the pink color. Sometimes there are like general admissions like in the whole around the world. Like we say, for example, people accept it like that. Pink color is for girls and the blue colors for guys, for gentlemen. So like I mentioned that I saw that actually in my friends, I have like some LGBT members in my friends, and they are like more interested about like art and architecture. So also they are so successful about that case. So what do you think about that?
about the meaning of purple, if it is more
for example, like in LGBT guys, like LGBT members, let's say,
No,
like they.
what I think about is that at this moment we are changing the paradigm of our culture,
Yeah.
and the LGBT, they are using that for express that they are alive and that they exist and they have rights. It don't mean, in my opinion, that they really like about that colors, you know, because
Okay.
if you can see, it's just a branding for them. So they use that just to show to others like them that they are there. So they are
Oh.
different from the others. So they say that they want to be linked with the community, but in reality, what I believe is that they want to show that they are different, but they should be accepted. So that's what I believe. And that's why they are wearing and using and saying that they like that colors, not because they like, but because they are linked to them. That's the idea. And at the same time, other persons that they could also like the colors, they are not wearing because they don't want to be linked with them. So it's quite complicated, this subject, but I believe that this is more a question of branding than of feelings, you know.
Okay, thank you so much.
Thank you, Professor Miguel, again for the presentation. We can move to the next presenter, Associate Professor Dr. Muhittin Jiradi. Associate Professor Jiradi is faculty member in energy engineering and the leader of the energy modeling and simulation group in University of Southern Denmark. He got his PhD degree from the University of Nottingham in the field of sustainable energy technologies, and he has expertise in several areas, including energy efficient buildings, energy storage systems, modeling and simulation, etc. He will give us a presentation on the continuous commissioning for highly energy efficient future buildings. I would like to give the word to you, Dr. Muhittin, and it's our pleasure to have you here today. You could start your presentation.
Yes, thank you, Dr. Devrim, and thank you for inviting me, basically, to provide this presentation in front of this multidisciplinary research group. So I'll just try to share my screen.
Yes, we can see it now.
Right. Just put it in a slideshow. So you can see my screen now?
Yes, Dr. Muhittin.
Thank you very much. Thank you again, Dr. Devrim, for inviting. It's great, basically, to provide this short presentation, short talk about continuous commissioning for highly energy efficient future buildings. So it will be more like engineering-driven presentation in that aspect, and it's basically one of the major topics that we have been working on at the University of Southern Denmark here in my group. So just a bit of outline, I will talk about building commissioning and overall, and then a bit about energy performance cabin buildings, about the commissioning or continuous commissioning approach. I will present one of the tools that we have developed, and it's now in use in many or multiple buildings here in Denmark that aims to close the performance cabin buildings, about the design of the development of this, and the implementation of this tool in one of the case studies that we have. So just a bit about myself. I have a mechanical engineering background, and as Dr. Devrim mentioned, we have been together in Nottingham in our PhD's studies, and then later I joined the Southern University of Denmark, and now I am serving as an associate professor. So the University of Southern Denmark is one of the big 5 universities in Denmark, spread around the whole country. Of the ones of you who have been in Denmark, you know that it's made up of 3 main islands, and then the SDU, or University of Southern Denmark, is there across the islands. I work in the Center for Energy Informatics, and that's a center that do research, development, and innovation. We work in the field of smartness, including smart buildings, smart cities and communities, smart industries, energy networks, and energy business ecosystems. So basically what we try to do is to digitalize the overall energy sector. I am leading the building energy modeling and simulation group. So basically I have a group of very good professors, postdocs, PhD, and master students. We work in different areas of building modeling, including black box, gray box, white box models. for different applications, for energy improvement, for retrofitting, for optimization, for commissioning, and also in the field of digital twins. And one of our initiatives now in some of the projects also that we are going into a more detailed modeling to a city and district level. One also feature of what we do is that we develop tools, digital tools that can improve the performance of different sections of buildings, and those are some of the tools that can be used. The first one is about commissioning. The second is for building automation and building automation systems evaluation and assessment, and the last one about retrofitting. This is just a screenshot of some of the 3D drawings of buildings that we have been working on, some of schools, offices, national and international buildings, and we do building commissioning, or sort of building simulation for different reasons. What I will be actually concentrating today in my short talk is the work that we are doing in terms of continuous commissioning of energy efficient buildings, especially new buildings. And you always ask yourself, why bother about building performance? Why we need to concentrate on this? First of all, it's basically because you can save at least 30% on your energy bill just by doing very simple minor modifications in your building that can't, or that won't really cost you a lot. Like changing the heating set point in your building is not really something that you need to pay for, but it can save you a lot of energy savings, or lead to a lot of energy savings. Second, the energy cost is basically the largest cost in non-residential buildings, and basically we are living in a competitive, financially driven world, so energy cost is very important. One of the major...
I'm sorry, Davrom and Dr. Hidin, are you sharing your slides right now?
Yeah, I am.
Oh, okay, sorry, because I cannot see your slides moving. How about the rest?
Okay.
Really, you are sharing, Dr. Muhittin?
Yeah, I am.
Yeah,
okay.
I think it's stuck in the first slide. I think
okay.
You were talking very nice, very smoothly that I didn't even feel any need to follow slides.
So maybe I'll just share my whole screen then. Can you see that now?
Yeah, it's in the background. Okay, it's fine now.
Yeah, maybe I'll just try to go in. So can you see things changing?
Yes, now it is fine.
Okay, good. I mean, I will not really go back to whatever I said, but I said that we are from University of Southern Denmark with the Center of Informatics with our work, and basically our work in the building performance simulation. Those are some of the buildings that we have actually modeled, and basically I'm talking about why we need to concentrate on buildings. And I will end up this by saying that it's not only about energy performance of buildings, it's also about thermal comfort and indoor air quality. So that's basically what we feel when we live in buildings or when we use buildings. There are a lot of hidden costs, including performance gap, which we'll be talking about in a moment, maintenance costs and management costs. Those are important costs to consider, and there are, of course, challenges related to this. And finally, buildings are where we basically spend our majority of time in school, in university, and in offices, and in houses. So it's all about buildings. In this case, obviously, I will talk a bit about Denmark, as we are working the majority of our research nationally in Denmark. So it's not an exception. Still, Denmark consume or contribute, or buildings in Denmark contribute to around 40% of the energy consumption. And based on the Danish Building Research Institute, they actually estimate that we can save up to 75% on the energy consumption in buildings by 2050. That's a very big number to attain. So there is a need basically to reduce the energy consumption, especially with the very strict goals in 2030. I always like to include this figure in my presentations, and what this shows basically on the x-axis there, you can see the BR61, BR7. Those are the building regulations in Denmark. And what you see in the y-axis there in kilowatt hour per meter square per year, that's the maximum allowed energy consumption in the buildings, like a new building in that era. So for example, a new building that was built in 61, that was allowed to only, or to maximum consume, or maximally to consume around 400 kilowatt hour per meter square per year. If you just go for the 79, then this building, the same building, if it was up to be built from scratch, that needs only to consume a maximum of 200. And today we are talking about around 20 kilowatt hour per meter square per year. So you see how much things has been changing in like 50 years or so, from accepting 400 kilowatt hour per meter square per year to accepting now, or not even accepting, more than 20 kilowatt hour per meter square per year. So this shows basically the potential of all what we are doing in the building area. And talking a bit about commissioning, basically commissioning, I mean, is, and I just extracted this from the ASHRAE definition. It's actually a process that ensures that systems are designed, installed, tested, and operated and maintained to perform in conformity with the design. So you see, it's not only about designing, it's basically design, installation, operation, maintenance. So commissioning is all over the building life cycle. And the major goals, of course, providing a facility that you can actually use it in the best way possible, and also provide the facility managers the way to use this building in the right way. And also you as a user or occupant, you will be actually also able to use the maximum out, or to make the maximum out of your building. There are some cost savings reported in the literature, like commissioning can lead to a maximum of or around 20% reduction in operational costs in buildings, and that's initial commissioning when you hand over the building. The payback is fine, with around a maximum of 5 years, and of course it will lead to lower energy consumption and better operation of the building on the long way. What is the challenge basically in commissioning now, or in these days? The major challenge is that when you get an energy company or consultant, and they are building, and contractor, and they are building a new building for you, that building could be using the best out of all the technologies. However, the standard or the trend is that they finish the construction, they finish the overall technical installations and so on. They test the building at that point, and then they just hand this building to you, saying that everything is okay. And I think many of you, and we have already experienced that buildings could be okay at that level, but then maybe after 2 months, they are even in another perspective. And then we have seen some cases where buildings are consuming like 40 or 50% more energy just after 2 months of handing over the building. And that's basically due to the lack of feedback and the lack of continuous commissioning of the building. So that's basically providing the need, if you want, to implement a continuous commissioning performance evaluation of the building, and not only initial commissioning of this. And in countries like Denmark, for example, the government and the ministry are now basically in a way of going to force this as being one of the requirements in terms of continuous commissioning. Of course, not on all levels, but at least on a minimal basic level, to make sure that you as a user or a client, you don't really get a building that won't really work as expected, even though it has the best technical aspects. And as Yugi Berra said, in theory, there is no difference between theory and practice. And then in practice, there is. So problems actually don't arise in the design phase, or the majority of problems don't arise in the design phase. They would actually arise when you are using the building or operating in the building. So there is an urgent need to use or implement systematic and automated continuous commissioning. And this is basically what we have been doing in some of our projects that we are running currently, or we have completed. And the main aim of using this continuous commissioning is to make sure that the building is performing as expected from day one and throughout the operational phase. But also, it's a very important feat to fault detection and diagnostic, because if you are actually monitoring the performance of the building, you can, as soon as possible, capture problems or faults or issues or anomalies, whatever, in any component. Like, for example, a fan is off, or basically a heat exchanger is not performing as expected, or a degradation is someplace, or whatever. So you can capture this by performing this continuous commissioning. Just a figure from a US study with 26 buildings that has been implementing continuous commissioning, and you see that some of buildings have reached 35% savings, and some others reach 22 or 20. So there are like some savings that you can reach in terms of implementing this continuous commissioning of buildings. So what about the tool that we developed? It's called OBIPME, and that's basically a tool that we have developed in one of the projects that I was running in the center. And it's called Online Building Energy Performance Monitoring and Evaluation Tool. So that's a tool that basically, or let's say it's an application that you can use to run an automated and continuous commissioning process in your building. And in the same time, it will also alarm you on any errors or faults or problems that arise in the performance or basically in the operation of the building. So if you want to read more about the tool, I will not really talk a lot basically because we have very limited time, but there is a paper that we published at in Energy and Buildings, which you can basically read more about this tool. And also there is like connected papers in the implementation of the tool and so on. But the main highlight of the tool basically is that it made up of two main pillars. The main pillar or the one of the pillars is data that you're getting from building. And today we are living in the digitalized world. Everyone is using sensors, meters, whatever in the building. So data is one side or one on one hand, and then on the other hand, you actually have simulations and predictions. So you have a very good model predicting how the building is going to perform. And then you can automatically and continuously compare both of them together and check if the real building performance is going as expected or it's drifting from that expected performance. So the overall perspective of implementing the tool is, first of all, of course, you need a dynamic energy model. In this study, for example, we used Energy Plus for that model. That's a whole building dynamic model that we developed. You can use weather station data, you can use occupancy data, you can use operational data to calibrate the performance of the building. And then, of course, as I said, continuously, you will compare that model predictions to the data that you're getting from the building. So in this presentation, I will show the implementation of this in one of the case studies, but this only also to show that, and this is basically why we are working as a team in this Center of Energy Informatics. So I am an engineer, basically. I'm a mechanical engineer, so I'm not really a software guy or basically a computer science person, but we have a lot of collaboration in the center between software engineers, computer scientists, and engineers, or applied physicists if you want. And that's why we also build software components, dashboard to show and monitor the performance. So basically that's the whole application in that aspect. So we actually combine the software part with the technical part, and then we can make out the best, or we can make the best out of our application. So the implementation on OU 44 building case study, I mean, the building OU 44 is one of our buildings at the University of Southern Denmark. Sorry, that's an 8,500 meter square building with 3 stories, 1 basement. It was built in 2015, and it actually complied with the highest building regulation in Denmark. That's the BR 2020. So we almost have everything about the building. That's why basically we try to model it, or we have developed a model for the building. The building is loaded with many meters and sensors and different counters and so on, as you see in this list here. So basically, we try to have this building as our living lab. So we test technologies, we test applications, and so on. And that's why we actually added all those different meters and sensors. But of course, this would not be the case of any real building. And that's why we are also implementing OPME in real buildings. So that's why we actually developed the tool to be more scalable and generic. So if you have a building like this with 64 electricity meters, you can use that tool. But also if you have a building, normal building with 5 meters, you can also use that tool for that. Sorry. And that's that's the way that we are actually building the whole building energy model development, starting with drawing in SketchUp and then going to OpenStudio for the model development or the characteristics development, and Energy Plus for simulation. And that's the building 3D model that we developed in SketchUp. You see it has 3 floors, it has 190 zones, it has 4 ventilation systems, district heating loop, and we have almost information about everything in the building. This is basically the occupancy counts that we have from the building, from cameras, and then we use this to calibrate basically the performance of the model, to make sure that the model predict the actual performance of the building as expected. This is basically some of the calibration, and you see in red the simulated numbers, and then in green the actual numbers. The first one, for example, is for the heating simulation, the second one for lighting, the third one for one of the ventilation system, and the second one also is a ventilation system. So we actually calibrated the model to make sure that the model is validated and can be used as a basis for commissioning of the building performance. We developed actually a dashboard. This is just a screen from one of our computers, but we have this dashboard in a very big screen in the building that can shows how the building is performing all the way. This is how actually the dashboard report. This is one screenshot from the dashboard. And you can see basically a lot of different tabs here: electricity, heating, solar cell, floor lighting, each floor, and then the 4 ventilation units. And what a percentage show there is actually the drifting or the gap or the performance gap between the expected performance and the actual performance. So between the simulations and the actual data that you got from the building. And of course, if this gap is increasing all the time, so it has actually built up. So you have a gap of 5%, and then next day 10%, and the day after 15%. So you know that there is something wrong happening into your building. This is just a case. We actually have been running this tool in our building for like around 2 years now or so, like year and a half. Of course, we stopped a bit in the COVID era, in the COVID situation, but we are now running it again. This is just an extract of one of the malfunctioning ventilation systems that we have. And then you see actually in this drawing or in this figure, the period from 20 November to around 29 November. And then in each day, you have this blue point, basically. And this blue point is the performance gap. So we start with minus 5% or 5% difference. And then we go to around 20 or 30. And then we go basically down to 90 and so on. So you have those 2 points in the middle there. Those are weekends. And that's why the number is very big there. But if you just ignore this and you take the overall line in the weekdays, you see that there is something building. There's a problem basically being built there. And of course, you could just have this problem going for maybe 3 weeks, 4 weeks, 1 month, and it will be unnoticed if it's a small problem. So in this case, we actually figured out that there is something wrong with this ventilation system after 4 or 5 days or so on. And then what we have done is actually we checked the rooms that are supported by this ventilation system. And there would be like, or there was one room, this called U181. This is one of the largest teaching rooms in the building. I mean, it looks like this room was ordering air all the time in this period. So from 20 November to 29 November, this room was needing air all the time, even at nighttime. And you can see basically the drawing here that I added. That shows the CO2 level in green, and that shows the valve opening, if you want, or the VAV opening of the ventilation system. And the VAV opening is 100% all the time, for example, in this day, in this period. And the CO2 level is never above 900, as you see. And the control logic in the building is that this VAV opening is never 100%, except if the CO2 is above 900. And then looking at this basically also show you that there has been a problem in the building in this period. And then, of course, we just provided an alarm for our technical services system, and they actually checked the building itself and try to see if there is something going wrong, basically, with this room. And then it's in fact was a VAV diffuser controller that was basically defected. And this is alone basically has avoided around 2,700 Danish crowns in operational costs. But this is just one case basically that we found in this building. One other case that I didn't include it here, but it was more about a heat exchanger that was clogged for some certain waste and the impact of those snow aspects in that level. So some problems can arise in your building, and you would never be able actually to catch all those problems just by seeing or taking a look in the building. When you have something more systematic and more like an approach that you can implement, like for example the tool that we are using or the application that we are using, then of course you can track the performance, you can monitor the performance, and then you can interfere as soon as you can in this building, at least technical services departments. That was my presentation, my short presentation in terms of what we do in terms of continuous commissioning. But as I said, we also do a lot of work in terms of retrofitting of buildings, control and optimization using digital twins, and also city level modeling. So if you have any more questions on the other aspects as well, feel free to send me an email or try to get in touch with me in that way. And if you have questions about my presentation, please go ahead.
Yes, everybody, if you have any questions, please feel free to ask your questions to Muhittin. Anyway, I have a question, Dr. Muhittin. So this technology is something at which scale you are in now? Like, is it something that we can upload it to our mobile phones and check it regularly as a house owner? What is the stage of the development now?
So it's actually, I mean, this application, I mean, normally we have, we have some sort of, I mean, this one it was built based on a national project collaboration. And we actually have a couple of industrial partners in this project. Like in this project it was Schneider Electric and a company here called Rimoni. And then of course, the authority, or basically the responsibility of the tool, is a responsibility of the partners, all the partners. And then the industrial partners are the one who are implementing this. So like Schneider Electric, for example, is the one who is implementing this application in some of the building. So it's not really an open source application in that aspect, but it's more like a product now in terms of buildings performance.
Yeah, of course, because like the physical equipment should be first installed to the building, right, and then right, the company should provide the software to the end user, I think.
Yeah, and of course you need someone to track the performance, because you know, if for example you as a user just get this tool to be working, there needs someone to take a look on the data and see how the performance is going, and then to check the systems and so on. So there will be this direct link between technical services in the buildings and the company or the consultant, or basically the industrial partner. And I can say that this tool in specific here is devoted to big buildings, like big offices, like a teaching building like this one, or facilities or so on, because that's basically would provide more added value in that way. So I won't really add this one to a single house, because you want first have all the technical services there, and it's basically not really valuable in terms of what you can get.
Yeah, but I think the way that you made it, just showing the percentage deviation than the target, is also making making it easy for the end users, because even if they are not very familiar with energy systems, if you just tell them when you see it is negative percentage, inform us, it's something that they can track it.
Exactly. And this is the difference between, for example, like what I show in this percentage dashboard, and what you can get as a technical service on the back end of this. So there's also, of course, data on the back end behind the dashboard. So you, for example, we implemented this in one of the hospitals here, and then you as a patient going in the hospital, you take a look on this big screen, and then you see that one of the ventilation system has like -7% or -20% or so. That can be maybe enough for you to understand that there is something wrong, or maybe there is something good or whatever. But as a technical services manager inside the hospital, they have also access to other data. And this is basically maybe the real-time data and the historical predictions and all the figures and so on, which of course, as a normal user don't really need to go in that way. So I think we differentiated between a very informative, user-friendly dashboard and very, let's say, hectic simulations and data on the behind.
Yeah, it was very nice, very helpful, Muhittin, getting this knowledge. Thank you very much for the presentation and for your contribution. I think we can move to the next presenter then, because we already exceed the time too much. Thanks again, and hope to see you soon.
Thank you. See you then. Bye-bye.
Thank you. Bye-bye. So our next presenter, the last one, is Dr. Pervin Abohorlu from Cyprus International University. She gained her PhD degree from the University of Nottingham. She had experience in the field of evaporative cooling applications. In fact, Dr. Pervin is an architect. However, her PhD specialization is in the field of energy. So this mixed background, I think, could lead us to a very interesting road So I want to give the word to Dr. Pervin about her presentation.
Thank you very much, Devrim Hocam, for your words. And I would like to express my gratitude to the organizing committee and especially you, Devrim Hocam, for your kind invitation. And thank you for giving me such an opportunity to attend this conference, stimulating and really exciting conference, actually. And I believe that this conference is a huge success in integrating different research ideas and multidisciplinary perspectives from leading scientists, experts, and academicians across the world. So today, in my presentation, I try to overview the history of passive solar design, beginning from the ancient age, and analyze the technological information regarding the use of solar energy. So I'll try to give a brief information, then I'll try to keep it short in 20 minutes. So feel free to stop me if I continue to talk a lot. I'm gonna give a brief information about the historical background and how it is applied in any structure by overviewing some recent studies. So basically today, I'll try to focus on the direct gain, evaporative cooling, and the radiative cooling from the historical point of view and the technological perspectives. So let's explore the history behind the applications of solar energy. So actually, everything is starting by seeking a shelter. So try to control the influence of weather conditions or dangers from animals. So wolves, bears, and early men are all dwelled in cave. And from the very beginning, people used various forms of shelter, including various pits, caves, recessed cuts, rocks, and any caves that we can see over here. Then fire was invented, and smoke caused men to build a cave that would ventilate the air, but on the other side to keep the heat inside, to store the heat inside. So that is the first time that people start to influence or manipulate their environment and attempt to regulate their comfort level within the occupied area. So those examples are, let me close it. Oh, those examples are from the China, from the Mata, and this example is from Cyprus in far west part, and it was used as a house or a tombs that was really cited in many years ago. And let's see what the other elements tackle with the thermal comfort issue. So here is, pardon. So in these native settlements, let's say, the housing are south-facing village, step up to give each home full access of sun energy. So that massive structure stored the heat during the sunny day and for giving off during the nighttime when the air temperature reduced. So it is very obvious that mostly used areas that we can see over here are all located where the sun, where exposed more sunlight. So storage or other services, other rooms, which are not used mostly, are located at the back part of the spaces. So these are very, very simple approach, very simple ideas to have the idea of exposing our building to sunlight. When we check these examples, it is from Colorado example, and imagine yourself living in a site of a cliff, and these Puebloan peoples are built more than 600 structures like that, and that are mostly used as a residential building. Some of them are used as a storage and the retail collections. So they are all south-facing cliff dwellings to capture the winter sun, as you can see from these sections as well. And it was protected from the summer sun due to the high angle of the incoming sun. And basically we can say that these are the really earliest traditional components of passive solar design. When we go back to the that slides, it is the very famous Socrates sun-tempered house, and it was indicated that with that example, solar energy has been used even in more advanced or practical way to provide heat and lighting for homes, and that is also indicated in his book. That initiates the use of solar energy to heat homes, actually. So based on this traditional practice, let's say, a satisfactory indoor comfort has been achieved by considering the climate first and the sun behavior, actually. So in that manner, building envelope as one of the important key gain importance since it exposes sunlight. So the building envelope or skin, let's say, of any building is a very significant element of the design. And as it can have a huge impact on thermally comfortable indoor environments. And when we look through the vernacular building design approach, as you can see in these slides, local materials has been used predominantly as a building material since it is very easy to find. An example of traditional use of adobe material in Cyprus can be seen in this screen as well, in this slide as well. And as it is very well known, adobe material is a high thermal mass material, as they have the ability to store thermal energy for a long time and subsequently release outside when the temperature reduced. But today, we can say that building envelope do not just composed of massive walls with a few or small transparent opening anymore. So let's go through these today's technologies. In the last decades, the developments of material science offers great opportunities for the realizations and the application of innovative envelope components. Dynamic windows, for example, provide benefits in terms of energy efficiency, thermal comfort, architectural quality of the building as well. So they aimed is not just reducing the heat lost, but also controlling the incoming sun in order to increase the solar gain in winter and minimize it in summer, and providing natural lighting without glare, actually. So based on these several studies, the following building materials and facade technologies, such as PCMs, thermotropic, photochromic, coating with membranes with selective optical properties, and etc., provides promising applications in the building facade. And let's continue with the other slides. It was taken from recent studies, and several researchers has emphasized the importance of multifunctional facade as a scheme to react the outdoor and the indoor environmental conditions, and also utilizations of renewable energy sources. So that is one of the example actress prototype. So it's a multifunctional facade module as far as I research about it, and it consists of an opaque and the transparent sub-module. And the opaque one, as you can see over here, the opaque one consists of a ventilated facade. Thank you very much. Ventilated facade with PV panels in order to power the fans and the shading devices. And the TCM part, which consists of two glazing, and the lower glazing is a triple low E coated glazed unit with argon. And the outer cavity is hosting a high reflective low E coated Venetian blind. And the upper part is made of triple glazing, and the outer cavity is with aerogel and translucent granular materials. And the inner cavity is also filled with the argon. So in that slide, maybe it could be emphasized that the multifunctional facades alternatively may be also referred as an adaptive building elements, kinetic, smart, and switchable envelopes. So as we can see in here, adaptable building elements can be assumed with different appearance, as we can see over here, in terms of maybe by kinetic facades with the different systems. So let's continue with the traditional traditional or historical backgrounds of the evaporative cooling. Is one of the, as it is most known, it's one of the sustainable cooling methods that reduce the building interior air temperature, and that method has been used in prehistoric eras in very hot regions. And with that example, one of the famous architects placed that porous clay pottery jar filled with water in front of the windows to create a air ventilation or cool ventilation, let's say. And the other Muscate's methods, placing a porous wet pot in front of a window to, let's say, pardon, I have to admit new one. Okay, so the other example is we can call it as a natural fridge, evaporative food cooler, as you can see. So it keeps the products fresh by keeping the fabric around the shelves wet. And the simplest way, as we all know, keeping the soil wet for cooling, sensational cooling effect. So these are all the very, very traditional way of creating evaporation. So from the historical background or the knowledge, we can realize that the material is important for evaporation effect. So the pad materials, the evaporative cooling pad materials play a vital role for increasing the cooling efficiency of the EC system. So that pad material should have a higher water holding capacity, porosity, thermal conductivity, and etc. properties. And in the last decades, research are ongoing to develop new pad materials for improving the efficiency and the cooling potentials of the EC systems. And many materials like metal, cellulosic basic materials, aspen, plastic, rigid medium pad is mostly investigated as evaporative cooling materials. And in that study, pervious concrete is used as a cooling pad for evaporative cooling device, although it's not a new material, but based on the experimental results, that wall assembly, as you can see over here, that wall assembly lowers the interior surface temperature of the concrete by 9 to 11 degree Fahrenheit. And the interior air temperature is also reduced. So that is one of the recent studies that I observed. And in that example, it is basically a local materials they use, shisha panels they are using. And they demonstrated it as a passive solar cooling system, passive cooling systems for settlements in hot and dry regions. And based on the simulations, the results shows that compared to the conventional cross ventilation, the highest air distribution in the room was achieved when these Shifa panels are used in two opposite sides, as you can see over here. So it's also show that that create a most uniform air compared to other demonstrations or simulations, let's say, and also show that the significant enhancement in airflow and airspeed also created compared to the using of the conventional windows. Continue with the following examples. They were used the porous pipes as a wall elements for that model room that you can see, and it examines the thermal performance of the water-soaked porous wall based on the field experiments for adjacent spaces. And the results show that that pipes are capable of reducing ambient air temperature by around 2 degrees Celsius, and providing a comfortable and environmental conditions for the indoors. And this is another interesting historical background for the radiative cooling methods. So this is an ancient hypocast. It's a kind of central heating system for Roman bath. So basically that air or water is warmed by using a fire sources. It could be a wood furnace, for instance, and that air or water is passed through these passages to create a warm raised floor over here. So this is a very, for me, very, very basic historical knowledge for underground heating systems. And when we come today, before we came today, let's see another example from Cyprus as well. And it was also built in during the Roman and the late Roman periods. It's in Limassol, the Roman bath, as an example. And let's come to today. So we can see the double skin facade example. So it's composed of a multi-layered structures and ventilated buffer spaces in between them. So are one of the most widely used passive elements that are integrated with the buildings. And the aim is, of course, reducing the cooling loads. And this reduction is due to the airflow induced in the air cavity by the buoyancy forces when the solar radiation hits the outer layer of the facade. So design and construction of ventilated facades have become a popular way to improve the thermal performance of envelopes in modern or contemporary buildings nowadays. So these air layers provide multiple benefits to building envelopes, including improving their thermal insulations or creating a fresh air, heating, lighting, even cooling, etc. And the different design solutions have been currently studying by many researchers, and this is one of them. And hybrid ventilated double skin facade, similar to the traditional double skin facade, it operates as an outdoor curtain, especially in summer, in order to reduce the cooling loads. So PV also integrated over there to power up the fans to exhaust the air outside. And of course, for the winter periods, that facade acts as a thermal buffer by keeping the warm air inside. And for the other research, it was also a recent studies, and they are using different materials over there, 2 different materials for testing the radiant floor heating system. The model with polyethylene pipe and the capillary tube. So what it was written over there, the model with CT models maintains the floor surface temperature more stable than the PB model. And the thermal comfort for the model with CT at a hot water supply temperature around 40 degrees is better than that of the model with PP, which has a water supply temperature of 55 degrees Celsius. So this shows us that the new materials with different conditions, let's say, are still testing for increasing the performance of the systems. And for the roof design, theoretically, the roof is the best location to place those RC emitters compared to other building envelopes. So in here, as you can see, there are some conceptual drawings of the typical water-based and air-based RC system configured in different ways to utilize the cooling from radiant cooling elements. And that is another patent, let's say, studies.
Pervin Hocam, sorry for interrupting, but I think Zoom has a limited time.
Tamam,
so if
tamam
you could
hocam.
Speed up and finish it,
Tamam
summing
hocam.
up in a moment,
Okay.
it would be great.
Tamam, tamam. Thank you, hocam. In this example, the ceramic thermal conditioning panel is used for heating and cooling operated by the circulating water through the capillary tubing, provide, let's say, efficient comfort levels for the users and energy for the energy savings as well. So I can say that these panels provide more improved comfort and incorporating renewable energies to the system, while the solar panels, as you can see, that was fixed in the roof. So I'll try my best to keep it short. And the last one is the cold tube. That is quite interesting for me. It takes the advantage of how heat is naturally driven from hotter surfaces to a cooler surfaces via radiation. And it's a novel membrane that air is tight and repels humidity to avoid the form of the condensation. And that cold tube works by absorbing the heat directly by the radiation from a person without cooling the air passing over the skin. So it was indicated that that can be used instead of using air conditioning system in the hot climates. And in addition to that, and I think this is the most important part of that, it also reduces the risk of indoor spread of infections, diseases, and also lowers the energy consumptions of the buildings as well. And lastly, as the remarks, I want to focus on 3 points over here. So the first one, all right, there are plenty number of different technologies, building integrated energy technologies have been developed in the past year, but from my point of view, a very few of them are used in real life practices. So for the crucial development of the building integrated, those factors like architectural aesthetics, effective functionality, low cost, practicality in integration and operation, and competitiveness with existing technologies should be considered. The other remarks is definitely the multidisciplinary approach. And lastly, we don't need to discover the new world again. It's already in the past. So keep inspired from the past. Thank you. Sorry for that. I try to keep it short.
Thank you, Dr. Pervin. Actually, if you keep your screen open for a moment, I think the last concluding remarks is briefly mentioning the overall discussion in this conference. Somehow, as we had today, different researchers from different areas, some of them are from historical renovation of the buildings. Some researchers were from mechanical, thermal sciences. Some of them were architects. Some of them were energy scientists. And the overall approach is actually developing somehow useful technologies, but at the same time, something that is practical and simple to use. Only in that case, I think we can roll out any technology commercially and make it something to serve for the sustainability. I think we already exceeded time too much. I just want to thank one by one to Professor Olympia, Dr. Hassela, Dr. Francesco, Dr. Murat, Dr. Mahmoud Sami, Dr. Melik Ziya, Dr. Meltem Vatan, Dr. Miguel, Dr. Muhiddin, and lastly, Dr. Pervin. I really enjoyed today listening very different, very broad presentations, but as an overall serving for a single purpose for sustainable development and potential improvement of the life. It was a real pleasure to be together. Actually, it was even beyond my expectations, very high quality presentations, very deep ideas, very different ideas. Thank you again. I also would like to inform you that next year, the fourth of the conference will be in Portugal, and it will be face-to-face. So I hope to see everybody there. I hope we can gather there and have again a fruitful discussion, a nice organization there, where we can share novel ideas together. That's all actually from me. Everybody had a very nice contribution. I would like to thank also to the attendees, listeners, some very valuable questions raised, and eventually we had some deep discussion here. If you have any questions or any word to say before we close, please, I can give the word to anybody. Is there any questions? Okay, thank you again. We are closing. Hope to see everybody soon. Take care and all the best.